and energy efficient buildings, which is being organized by Civil Engineering Department of National Institute of Technical Teachers Training and Research, Chandigarh. I welcome all the participants and all the various centers. We have 6 centers connected to us. First center is Siddharth Institute of Technology, Vijayawada, Andhra Pradesh. Then we have with us Baddi University of Emerging Sciences and Technology from Baddi HP. We have Gyani Jail Singh Institute from Bathinda. We have Indo Global Colleges from Abhipur, Mohali. We have Ramchandra Khitan Polytechnic from Jaipur. And we have Indian Institute of Technology and Management for Kanpur. So I myself is Himi Gupta. I am Assistant Professor with Civil Engineering Department, one of the coordinator for this program. And I'm joined today by Dr. Sanjay Sharma, who is also the coordinator for this program. I would request Dr. Sharma to kindly give a brief about the program.
Good morning, everybody at NITTTRCHD and also at the various centers. This program, which on green energy efficient buildings, we are starting today and this is a 1-week program. Will be over on Friday, that is on 4th of March. As you know that because of global warming and climate change and other related environment issues, this particular aspect of construction of buildings, how to make our building more say environment friendly, and even during construction also, and while using those buildings, how to take care of this aspect into consideration, that okay, there is a minimum impact of buildings on the environment. So that aspect we will be discussing during these 5 days. We have invited experts from various organizations who are working in this area. So we will be having sessions on okay, what is the importance of green buildings, okay, what is the need of having green buildings. Maybe that will be an introductory session, which will be followed by the various rating systems. Which is okay, there are different agencies who are working in this area, and then okay, how to get yourself your building rated as a green building. That will be that is an important aspect. And then we will be taking most probably every aspect of green building practices one by one, like what are the say building envelope, and then so what are the sustainable construction practices for this thing. Then your energy efficiency is one of the components which we will be taking care of this thing, that okay, how to take care of your energy needs and how to reduce the energy utilization in a building and use the natural resources and natural lighting and other energy efficient fixtures in the building. Another important aspect is the water use and water efficiency in the buildings, and that is also the one session which which will be taken by the experts from the TERI, which will be basically the expert will be delivering the lecture online from Delhi. Then we have energy ECBC. This thing is very, very important. Then another aspect is okay, lighting and HAVC for the green buildings, then architectural considerations, and few case studies, how various buildings, how they have been performing, and how they what are the various features of those green buildings. That will be discussed in one of the sessions. And of course materials and then indoor air quality are the two aspects which will be discussed during this program. And then one session on Tuesday we are having on the panel discussion, where we are inviting a few experts, and where we can interact with those experts, and let us see what are our queries. So we will try to get those answers from our panelists. So that is the program, and I hope that we have I think now we can go to the various centers one by one, and then if you have anybody invited somebody expert at this center, so one by one I will be inviting the maybe some chief guest or some other your dignitary is there, so we can speak about for 5 to 10 minutes, and then you can introduce yourself there also. So first I will like to invite uh, this Prasad V. Potleri Siddhartha Institute of uh, PVP Siddhartha Institute of Technology, Vijayawada.
Hello, good morning, sir.
Yeah.
Hello.
You are audible.
Hello, good morning, sir.
Good morning.
Sir, I'm KV Subhash. Assistant Professor in PVP Siddhartha. Hello, sir.
Please welcome. You are audible. We are listening to you. Okay. Yes. How many participants do you have?
20 faculty members, sir.
Okay, fine.
And 25 students, sir.
Okay.
BTech students, sir.
BTech students. Okay. Yeah.
Right.
Do you have anybody with you, or you want to say something else?
Until now, our professor were there, sir. KVG K. Rao. He had a class and he had gone, sir.
Okay.
We were interested in participating in this workshop, sir. And our faculty members were also showing interest towards this research on the green buildings, since it were not in a curriculum. Right, sir.
Okay. So you are, I again welcome all the participants, and I think you are having this program schedule with you, so we will be following that schedule, and whenever I think you want to interact, you can always interact with the experts or who is taking the lecture. So once again I welcome you, and then we can move to the next institute, and maybe we can have Indo-Global Colleges. You are not audible, Ritu. आपकी आवाज नहीं आ रही है. Okay, till I think they are having some problem, so we can kindly sort out the problem at your end, and now we can move to Badi University is connected. No, Badi University is not connected. That means even Ramchandra Khaitan Polytechnic is not connected. Okay, and then Indus Institute of Technology and Management, Kanpur. Yes, we can go to Kanpur.
Yes, myself Vijay Kumar Dixit, and I am Assistant Professor at HOD Electronics Department, Indus Institute of Technology Management. Sir, we two persons are associated with you, with me, Mr. Nitin Agarwal, HOD Civil Engineering.
Okay, yeah, welcome.
We both are working on the green building program for our college. And we are also going for Solar City program under the Ministry of New and Renewable Energy.
MNRE, yeah.
Yes. For that, we are also want some support from your side. We will ask some questions regarding this, so we can easily go for this.
Okay, yeah. So because I think our if you find our this topics and schedule, so I think major emphasis on having energy efficiency in the buildings. So I think that aspect will be greatly covered. So we'll try to cover this thing in the how many participants you are having with
Sir,
you?
We are two.
Okay.
Mr. Nitin Agarwal, HOD Civil Engineering Department.
Okay.
Myself, Vijay Kumar Dixit.
Okay.
HOD Electronics Department.
Okay. And no other faculty member is there. You can, if you want, you can bring your students also. That means.
Sir, at the present, some exam is running in our college.
Okay. So how many? That means you are two only registered for this program.
Yes, sir.
Okay. In any case, there is no problem. You can get the benefit of the expertise.
This material to our student.
Yeah. That's good.
Future our student will also participate in this type of program.
Fine. That's fine. Okay. Now we can go to the next institute. That is the Baddi University, Indo Global. ज्ञानी जैल सिंह लास्ट में जाते हैं. आई थिंक द डायरेक्टर इज देयर, तो ही विल दिस थिंग. क्या खितान पॉलिटेक्निक कनेक्टेड नहीं, कनेक्टेड नहीं है. ओके, देन आई थिंक वी कैन गो टू ज्ञानी जैल सिंह यूनिवर्सिटी एट बठिंडा, महाराजा रंजीत सिंह यूनिवर्सिटी एट बठिंडा. या
Hello.
या
This is GS Bhatt, HOD Civil.
हाँ जी भट्ट साहब, आपको गुड मॉर्निंग.
Good morning to all of you. This is GS Bhatt, HOD Civil Engineering Department, and our center is connected with you very well. And we have around 59 applicants, and most of them are present. We have a little problem. Mid semester exam is going on. A participant will go there for the examination duty, and we are waiting our director. He is,
And we can come back to you again, maybe after 5-10 minutes when he comes.
Yeah, he will be here within few minutes. Yeah.
Okay. So we go to other this thing, then we will again reconnect with you.
Okay. Thank you, sir.
Yeah. Thank you. So Indo Global आया था. या आवाज नहीं आ रही. कौन सा
अब हम जा रहे हैं वो आ गया
बद्दी कर दो. Baddi University. Okay, now I think in the meantime we can go to Baddi University.
अपन दिखाइए बोलिए सर
वो वहां से म्यूट करो, म्यूट हुआ अनम्यूट करो.
हाँ, किसकी? बद्दी यूनिवर्सिटी. आपकी आवाज आ रही है ऋषभ जी?
हाँ सर, our chief guest is just coming, so please
Okay.
give us 5 minutes.
Okay. फिल्म चला दो.
बुला चलाऊंगा सर को.
अभी तो मेरे पास भी पड़ी तो है, वो उसकी है तो यहाँ से ले लेते. चलो उसकी चला सकते थे, वो इडिटेड कंक्रीट ब्लॉक्स की है. एक दो फिल्म लेके रख लेंगे वो लीजिए. ओके. बद्दी यूनिवर्सिटी से somebody is coming. चीफ गेस्ट आ रहे हैं आपके ऋतु? अच्छा.
Hello.
Hello.
Yes, sir. So this is Ritu Goyal from Indo Global College of Engineering.
आप नो आपके सुनाई दे रहा
Good morning to all of you.
है?
So
गुड.
we are now connected to the ICT training which is there at NITTTRCHD.
Yes.
Now this will be the great platform for all the intellects who are sitting there because the global warming is a matter of issue right now. So we'll be gaining lots from this program as all of you know that building sector itself is consuming lots of energy. So besides me is our HOD Dean Academics Dr. Dinesh Chandan and he wants to be online and he'll be there and talking to you right now.
Yeah. Please, Anjit. Yeah. Welcome.
Hello.
Hello, Anjit. Good morning.
Good morning, sir. How are you?
Fine, fine. Please continue.
Sir, this is a great program. We will definitely be beneficial from it. And I have to make one request. Whatever the findings of this conference, we should convey these to the concerned departments also, like BNR department, public health, irrigation.
There's a right. Please welcome. Okay.
Thank you. Thank you, sir.
Jaipur आगे. Yeah, thank you very much. And now we can go to Jaipur. Baddi. Baddi. Yeah. Okay, Baddi University. Baddi University. Rishabh ji.
Sir, we are still waiting for our chief guest.
Okay. Then we can go to Bathinda then. But anybody else who want to speak, Rishabh ji, about the program and something else? In the meantime, you can. Somebody from your this thing. How many basically participants you have guys with you? Baddi? So,
50, sir.
50.
Around about 40 or 50, 50 participants.
Okay. So kindly, I will request all the centers to kindly prepare the list, and if you can email me, that will be good.
Okay, sir. Fine.
Yeah, by tomorrow you can send the basically details of the complete details of all the participants who have been
Right.
registered at various centers. So kindly do that, and yeah. So in the meantime, I think can we go to some other center? बठिंडा में उनके डायरेक्टर आ रहे थे.
कितने participants, sir?
बठिंडा, yes, director साहब has come.
चलो कोई नहीं, वो सारे
यानी जैल सिंह बठिंडा कर रहे हैं. 10 बजे का उन्होंने. इस बात में okay. कर देंगे तो. जयपुर भी जुड़ा, जयपुर नहीं जुड़ा, ओके। किसको किताब कोई बात, वो जुड़ेंगे, कोई बात नहीं, इसमें तो दो
ऊपर 20 प्लस 25 है, फैकल्टी 25 स्टूडेंट, बदली में 50
इन्होंने बताया दोनों ने। हाँ जी हाँ जी हाँ जी मत तो हाँ हाँ प्रॉब्लम आ रहा है कुछ। ओके 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 ट्राई तो वी विल कंटिन्यू। अभी तो हम क्या करेंगे, अभी ये उनके डायरेक्टर साहब भी वेट कर रहे हैं बठिंडा से, वंस ही कम्स तो उसका थोड़ा सा ओके ओके नो प्रॉब्लम नो प्रॉब्लम। चले जाते हैं, मैंने भी लेक्चर वो लेके नहीं आया इसमें।
है भी पहले आपके पास,
वो कॉपी करनी पड़ेगी, उसमें कॉपी हुई नहीं है, जाना पड़ेगा।
अच्छा ओके।
हेलो हाँ जी ज्ञानी जैल सिंह एट हेलो we can wait for
सर आपका माइक ऑफ है, एक्सटर्नल ऑन कर लीजिए उसे, इनका सिस्टम ट्राई कर रहा है। सर योर एक्सटर्नल माइक इज ऑफ, यू आर नॉट ऑडिबल।
आपका एक्सटर्नल माइक जो ऑफ है, आवाज नहीं आ रही।
सर आप इंटरनल माइक यूज करिए जो पहले कर रहे थे।
आवाज आने नहीं है।
बोल रहे हैं आप तो आवाज
अब की आवाज आ नहीं रही अभी, माइक नहीं बटी वो
डायरेक्टर भी
आई नहीं। एक काम करें, इनको कहते हैं कि टी ब्रेक कर लें। May I request all the coordinators at all the centers, because we are not able to connect with all the centers. There is some problem apart from one or two centers. So what we will do is that we will break here and for lunch, and let us give time at about it is 10:35. We will reassemble at 11:50. Khaitan Polytechnic. Okay, Khaitan Polytechnic, yeah.
Sir, good morning.
Good morning.
Good morning, sir.
From Sanjay Mathur from Khaitan Polytechnic, Jaipur.
Haan Mathur ji.
Sir. Yeah. So there is a problem with the net, so we just delayed some time.
Okay,
So
okay,
now,
please. Yeah.
so
So, so I think as we have been discussing, this is a 1 week program.
yes, sir. What's the problem? Sir, your voice is not clear.
So I think that is what we are deciding, that we will be reassembling exactly at 11:15. And may I request maybe at Bathinda or at Baddi University, so be sharp there with your whosoever is the basically the chief guest for the inaugural function, so that we will be giving about 10-15 minutes and we will be starting with the session. So we can break for another half an hour, and whatever the issues are there, so these can be sorted out, and we will be meeting again at 11:15.
हेलो ठीक नहीं नहीं मैम कोई चक्कर नहीं ठीक है हाँ जी ओके मैम
हेलो हम ठीक आंदी भी आवाज एक्सटर्नल लगाइए इस टाइम में दूसरा अच्छा ठीक है ही कर दें ठीक है सर ठीक है ओके हेलो इसी से बात करना
ठीक देख लिख के आगे।
ठीक है, अरे
अच्छा, ठीक
ठीक है। आप अच्छा
देखिए
क्लासरूम है अलग अलग।
देखिए इतने सारे इतने कॉन्फ्रेंस रूम में कर रखा है इन्होंने भी कॉन्फ्रेंस रूम में कर रखा है, ये कॉन्फ्रेंस में अकेले बैठी है ना, लेकिन बाकी लोग भी आएंगे और इधर भी देखो
ऐसे वो लोग भी हम लोग
एक
देख रहे होंगे।
एक जगह 50 लोग हैं कम से कम।
इतने सारे से कनेक्ट कर रखा है। ओके, यानी मल्टीपर्पज काम चल रहा है।
हाँ,
और हर जगह कई सारे लोग हैं। एक ने तो चीफ गेस्ट बुलाए हुए हैं, वो उनका इंतजार करने की वजह से चीफ गेस्ट ने जल्दी किया, जैसे वो आ जाएंगे
आपको कॉन्फ्रेंस रूम में
लेकिन उनका वैसे ही लेक्चर
ये कुछ उल्टा नहीं लग रहा है सबको? देखिए प्रोजेक्टर पीछे लगा हुआ है।
पीछे भी लगा हुआ है।
पीछे भी लगा है। अच्छा तो हम लोग हैं, अच्छा इसलिए आप साइड हो गए। ये सही तरीका
नहीं
अभी उनको बोलना है, उन्होंने वहाँ से दो उनके विषय में इंडो इंडो कौन से है, बद्दी यूनिवर्सिटी में, है ना? खड़े के बोल दे। नहीं लेक्चर तो वही देंगे, अभी वहाँ पे वो चल रहा है। Hello, so welcome back. Now I hope all the problems regarding connectivity, they have been solved. And now I will like to welcome VC of Baddi University of Emerging Technology. So, sir, can we have your address for all the centers?
Am I audible?
Yeah.
I, Rishabh Garg, on the behalf of Civil Engineering Department of Baddi University, heartily welcome our Honorable Vice Chancellor, Professor Dr. Shakti Kumar, as Chief Guest for this inaugural ceremony of short-term course on green building and energy efficient buildings. I also welcome all the deans, HODs and all the delegates for this workshop. I would like to introduce Professor Dr. Shakti Kumar. He has done his post-graduation from in Electronics and Communication from Birla Institute of Technology and Science, Pilani, and doctorate from NIT Kurukshetra. He is a seasoned academician with 29 years of rich experience in teaching, research, and administration. Before joining as Vice Chancellor, he has served the various distinguished positions such as Group Director, Campus Director, and Director Principal for about 16 years. Professor Kumar has served NIT Kurukshetra, Birla Institute of Science and Technology, Pilani, Dubai Campus, UAE, Atlim University, Ankara, Turkey, Chandigarh University, and various other organizations. He has published more than 200 research papers, 7 book articles, and he has organized more than 7 international and 10 national conferences. He has delivered around about 100 expert talks in India as well as abroad. 9 research scholars have already completed their doctorate degree under his supervision and 5 are on the way. He has completed 2 major research projects by MHRD and DRDO funded research projects. Professor Kumar has jointly awarded as Sir Thomas Ward Memorial Prize for his research work by Institution of Engineers in 2006 and 2010. He was also awarded as Rashtriya Nirman Award 2001 by International Business Council, New Delhi. He is a social worker and he has donated blood for about 25 times and so far. He is the president of Go Green International Organization India chapter. Apart from the academics, Professor Kumar is keen sports person and he has won bronze medal in the hammer throw at national level. So the list is so long and I cannot explain within such short of time. So now not taking much of time, I invite Professor Dr. Shakti Kumar to say a few words on this short-term course. Thank you, sir.
Okay. A very good morning to my esteemed colleagues and the participants. I believe that the enlightened society is needed in the future, and the enlightened society needs sustainable environment. Green and energy efficient buildings, from design, construction to demolish, contribute towards sustainable environment. We are electrical energy deficient at this stage. For our national growth, we need our industry, agriculture, and service revenues to grow. In order for industrial and agriculture produce to grow, we need a lot of energy, especially electrical energy. And energy saving and making energy efficient buildings does contribute towards as good as generation of new energy. The short-term course on green and energy efficient buildings is very timely. I convey my gratitude to Government of India, to the NITTTR for organizing such a beautiful short-term course. I also thank the resource personnel for enabling us to learn and disseminate this all important knowledge. I convey my best wishes for this short-term course. Thank you.
Thank you very much, sir, for your encouragement, and we hope that this program, at the end of the program, all the participants will feel entitled, and they will be eager to implement basically this green energy concepts in the existing buildings as well as in the new buildings. So thank you very much once again, and now we can go to the Batinda, Gyani Jal Singh Batinda. Nobody is there now. Okay. So anybody from Gyani Jal Singh College, Batinda? I think people are still assembling after tea. Can I have some information? Your director is Hondal Saab is coming or not? Any of the participants?
Hello.
इसका नंबर लगा दो, वो कौन सा लड़का था?
Hello, Gyani Jal Singh. Hello, Batinda. Yes, ma'am. Yes, ma'am. आप रिस्पॉन्स कर हेलो. Yes, ma'am. आप ही आ जाइए ना.
Hello.
Yes.
Yeah. Yeah. हाँ जी, please.
Sir, this is Amanpreet from Gyani Jal Singh.
हाँ जी, Amanpreet जी. Hondal Saab is coming?
Sir, actually they are in a meeting.
They are in a meeting. So
yes,
whenever in between he comes, I think we can spare 5 minutes. And,
yes, sir. Sure. I will inform you.
And then we can start with our first session.
Yes, sir.
Yeah. So welcome, my dear participants, after the say inaugural session, and now we will be starting our first session. This is the introductory session on the green buildings, and we will be discussing in this session about okay, what makes a building green, and a few case studies also, which are the in India, how many some buildings they have been constructed and what are their salient features. So with that we will be going ahead. Basically, why there is a need to construct or making the building greens, or maybe constructing building greens. As you know that there is a major environmental threats, and because of these threats we are having this problem of global warming, ozone depletion, acid rain, oil pollution, chemical pollution, and there is no doubt energy crisis. And as you know that the global temperature is rising, and if we are not able to control the rise of temperature, so what will happen is that okay, the life on this planet will become a little bit difficult, and there may be a season that okay, we are not and we are already basically feeling the effect of this climate change with in terms of having increased say change in the climate pattern, change in the your various you can say you are having extreme winter, you are having extreme summer, and we are having say extreme rainfall, and then there are also issues regarding say many rise of the sea level and all that. So basically all these issues are one of the major issues, and if we not attend to these issues, I think our life on this planet earth will become difficult. So and if you see that because of this global warming, I think the basic reason of global warming is the release of the various green gases. Because whatever the energy we are using is that okay, that energy is not the clean energy, and we are basically the energy we are using is it is a fossil based energy, and in terms of that, what we see that okay, there is a lot of carbon dioxide being thrown into the atmosphere, methane, chlorofluorocarbons, and nitrous oxides. This just slide shows that okay, what is the contribution of these various greenhouse gases towards the in making the basically towards the global warming cause. And as a effect of this, you are seeing that okay, there is a droughts, heat waves, and contaminated water supply, altered your crop pattern, desertification, and population movement, etc. So various these are the threats basically which we are facing right now, and we need to take care of this thing. And you can see the measures which we suggest have been suggested is okay to the global warming is that okay, discourage use of coal and fossil fuel, less consumption of petrol, use of solar, wind, and geothermal power, protection of forest, slowing down population growth, conservation of energy, and phasing out this chlorofluorocarbons. If you look into the various aspects that okay, well, how much our building sector, if we go into details of this, which is one of the major users of energy, and its carbon footprints, they are also having a major impact on the environment, and, and basically that is why we need to control the basically we need to construct the green buildings. And as per the target, basically we wanted to have lot of green say lot of areas under the green construction. So basically what we need is okay, we need the objective is to evolve a strategy to reduce energy use in building so as to reduce the energy cost and emission of the greenhouse gases into the earth's atmosphere. So that is the main objective, that okay, we want to reduce the basically we want to reduce the use of fossil based energy into our buildings, and indirectly what in basically what you see that in case of buildings, in your construction, your manufacturing of various materials, or other aspects, we are using lot of energy. Like if you are talking about cement, so when we say that manufacturing of cement, so we need a lot of energy for that purpose also, and during that manufacturing process we are throwing lot of uh, green gases into the atmosphere also. So basically the purpose is that okay, reduce of these this use of energy into the construction of buildings, and even afterwards also when we are using the building. So whenever we say green building, so green building basically will be designed or will be constructed and operated to minimize the total environmental impacts while enhancing user comfort and productivity. What we are basically focusing is that okay, we want to reduce minimum use of energy, and also at the same time without compromising with the comfort level of the residents. So this is what that okay, as per your this IPCC conference, it is found that the building sector is one of the major contributors of the emission of the greenhouse gases. If you see that 40% of global energy consumption is the building related. Out of the total, we get that 40% is building related. 50% of the global greenhouse gas emission are due to the buildings only. And 80% of global greenhouse gases emissions are attributed to the cities. 50% of the material sources taken from the nature are the again building related. So over 50% of national waste production comes from the building sector. So that is see that how much is the contribution of our building sector towards greenhouse gas emission and towards the environment pollution. Again, we see that majority of the urban consumptions are again attributed to the buildings. Similarly, the wastewater generation is again attributed to the residents and the urban population. So buildings again are that means that most of the buildings are basically causing lot of changes into the phenomena of the climate, and that is what we need to control. And it is seen that okay, wherever the high density building is there is an increased temperature, there is an increase in the ground level ozone, there is an increase in the contamination of the groundwater table, there is a depletion of vegetable cover and ecology, and impervious groundwater is leading to the flooding in various locations. So these are the basically threats which are there due to the environment due to the construction of the buildings, and we have to take care of these threats through construction of through using green technology into the for construction of our buildings. You should see that green building movement in India. So a lot of development is taking place, and now people are very much aware of the green construction practices. And you can say one of the major industry in India is the construction industry, and which is growing at a rate of 9.5% as against the global level of 5.5%. So because still this is a developing country, and there are a lot of construction activities going on. We in our for our infrastructure needs we require a lot of our infrastructure facilities, and that is why the construction rate it is very high as compared to the global level. So as the construction is going on, so preservation of the environment poses a lot of challenges, and that of the same time presents lot of opportunities also. So and what we need is that okay, our construction section should play a very positive role towards the maintenance of the environment, and green building movement is one of the steps in this direction. So basically what we are looking through construction and through green building is to minimize the negative impact of construction activity on the environment. We started basically in the year 2000, and from a minimum zero say footprint we had about in 2003 I think we covered about 20,000 square foot of the green construction area, and today there are about 150 green buildings with a footprint of 25 million square foot which have been constructed in India. So you can say lot of growth at a very faster pace is taking place, and you can say there is a lot of market also from green building materials and products. This is the just shows that okay, from starting in 2002 from 0 to I think now about 80 or more than 100 buildings have been constructed. This is a graph is little bit showing the data up to 2010 only, but and you can see that up to 2012 basically this is the market which is green that has a potential about 4,000 million US dollars. So it is a huge market, and huge basically opportunities are there, and we have to take care of these facilities, and we basically we should not be lagging behind regarding this. Okay, the one question which arises is why people should be attracted towards a green building. General, if awareness there, if awareness is not there, that means okay, we are not aware of this thing, so we have to look into the reasons okay why we should go for this thing. So basically if you see in for a green building there are operational savings. These savings basically if we construct a green building, so we will see that green building consumes about 40 to 50% less energy. about 20 to 30% less water as compared to a conventional building, and at the same time you may say the cost of construction is about 5 to 8% more, but again that cost payback period of that increased cost is about 3 to 5 years, and afterwards you can say you are going to the positive side only. And again it improves the productivity of the people also. As an indirect impact you can say it improves the productivity of the people working in the in a good working environment also. Again you get an enhanced air quality. That is also one of the basically added advantage of having the green buildings. And you can see this is the table which shows that in India various buildings which have been constructed. So if it is a CII Godrej building in Hyderabad, you can see that it has a built up area of 20,000 square feet. Rating achieved is platinum, and it was basically as compared to the conventional building about 20% cost was more, but that enhanced cost was recovered within the 7 years after its construction. Similarly, there is a ITC, so all this data shows that okay, the payback period for an enhanced cost ranging from 6 to 20% varies from 3 to 7 years. And all these buildings have been rated as a green buildings and having a large area under this thing. This is basically just shows that okay, what is the comparison of the initial cost of green building versus the this thing. So you can say about cost is initial cost is about 5 to 8% more as compared to our conventional building, but in terms of payback system it is basically on very high. So it is advantages to construct a green building. So this is the payback period. There is basically payback period generally ranges from 1 to 3 years. Average is the 1 to 3 years. So coming to this, okay, how we define a green building? Basic definition is a green building is the one which uses less energy, water and natural resources, which creates less waste and is healthier for the people living inside compared to a standard building. That means where we are looking for a building in which we are using less amount of energy, less amount of your water, at the same time also generating less amount of waste, and then also having a very healthy sort of a indoor environment. These are the various definitions which basically goes into which defines as per the EPA USA, a green building, also known as a sustainable building, is a structure that is designed, built, renovated, operated or reused in an ecological and resource efficient manner. The basic objectives of designing a green building is to protect the occupant's health, improve employees' productivity and use energy, water and other resources in an efficient way. So a green building is a building that incorporates design, construction, operation and maintenance practices which significantly reduce or eliminate the negative impact of development on the environment and its occupants. It addresses the needs, your energy needs, your basically efficiency, energy efficiency, greenhouse gas emission, abatement, water conservation, waste avoidance, enhance biodiversity, reduce natural resources consumption and productive and healthier environment. So green buildings, we can say any building can be a green building. It can be a house, individual house, it can be an office building, it can be a commercial building, it can be a school building or it can be an industrial building. So talking about benefits, that is already we have discussed that in terms of operational savings we are saving about at least 40 to 50% lesser energy and 20 to 30% lesser amount of water as compared to the conventional energies. Similarly, if it comes at an incremental cost of about 5 to 8%, but incremental cost gets paid back in 3 to 5 years time. Indirect benefits which we are getting is that this is a enhanced air quality, excellent daylighting, improved health and well-being of the occupants, conservation of your various resources and enhance the marketability for the project. Now, once we say that okay, what is a green building, now we understand that what are the various components which go into a construction of a green building. And the 5 components which basically are covered by various rating systems are the site selection, energy efficiency, water efficiency, material efficiency, and indoor air quality. These are the basically 5 features which different rating systems they have defined for getting a certificate for your building as a green building. So and our subsequent discussion in various sessions will be based on these particular parameters, like if we are talking about material, what are the materials, what are the in water efficiency, what is the criteria, how to achieve that water efficiency in a building. In energy efficiency, yes, how you can make the building more energy efficient, and how we can use different sort of fixtures or features which consuming lesser energy, or which otherwise which are your energy is based on your solar energy. So that sort of things basically we will be discussing in our subsequent chapter. And if we go define each and every aspect, this component one by one, so we'll see that site use means that minimization of land use for a building, which basically as you know, land is a very you can say most of the time it is not easily available. So basically we want to have a data surface site where minimum land is used. Then it is its location near the public transportation. Basically, what are the erosion prevention, water usage, and area that site is having. Then other techniques that reduce impact on the surrounding lands, like maybe some green area, some trees, some drainage areas, or natural drainage system. So they all go into the site use in a green building concept. Then you are having the energy efficiency. Energy efficiency means that okay, we are having a building structures, and then where we having the various electrical and mechanical systems, heating and other lighting, which use minimum energy while providing the same comfortable as compared to the conventional energy systems. There may be nowadays lot of other alternative sources of energies are available. So we are looking for those energies. At the same time, installation of the energy efficient systems and in our buildings, and also we are having those sort of materials which basically either improve or reduce the usage of your gain or heat gain or your heat loss into the building or from the building. So that is one this thing. And then water is one of the major requirements, and what we are looking in from a GAIL building, that it should be a water efficient structure. So that means that okay, we are whatever the water is being used, that minimum, there is a minimum use of the raw water, and through fixing, having say water efficient fixtures, reuse techniques in a building, and some other measures which should be adopted, which otherwise will reduce the usage of water in a building. Then of course material is one of the major areas in a building. Like I said, if you are using the cement, if you are using the bricks, so lot of energy goes into manufacturing of these materials. So and whatever you may say, even you talk about this finishing, about like tiles or maybe some other materials, so lot of energy is being used in the manufacturing of these materials. So basically we are looking for such materials which are using lesser energy while in their manufacturing process. So basically we are looking for recycled and easily regenerated or efficiently produced materials, and also building construction techniques that minimizes the materials required for a building. So those sort of techniques and those sort of materials we are looking into a green building. And at the same time, maintenance of good environment, indoor environmental quality is very important. That means that okay, we are having a good ventilation system, good daylighting, and other improvements to the indoor environment that increases the occupants' comfort and productivity level. So site selection, I say that basically the thing involved is choosing the location of the building, its building, its placement on the site, like compared to the sun direction, like in which area you are located, whether in which zones you are located, and that means whether you at what time you require sun energy, or what time you require the your light you want to enter into the building. So from that point of view, you have to place the building. So orientation of the building depending upon your location, geographically at which place you are located, so that becomes important in a site selection. Then your building shape, amount of the ground disturbed during the construction, and types of the surfaces that will remain when construction is finished. That means we are having paid surfaces, we have natural drainage system, or you are having a surrounded area which is green, or minimum disturbance to your surroundings. So those things basically will we are looking into it while we are looking into the site selection for a building. So the basic thing is that, okay, we enhance the overall quality of life by providing amenities within and closer to the site. So that means that we are looking for a area that site which is near to the public transport, or household services and amenities that are accessible by safe, convenient pedestrian pathways. And in multi-dwelling units, we provide seating areas, toilets in the common area, and toilets within the campus only. So those are the things we are looking for in case of a, then you have the second criteria is the natural topography or landscape that should have a minimum disturbance. And basically we should, that means that we are trying to design a building with a minimum footprints, but and then consider retaining the natural land space in the site to the extent possible. And where we have the fully grown trees, we avoid destruction of those trees, avoid developing paved surface on the city sites such as much as possible. So, and another thing is avoiding the heat effect on the roof. So we just want to reduce the heat islands, that is thermal gradient difference between developed and the undeveloped areas, to minimize the impact on the microclimate. If we are having a, say, obstruction, or say in the sun path, it is our building is coming, that means that we will be unnecessarily gaining the heat. So we want to have reduce that sort of a thing on the building by giving a proper orientation to the building. So we have to see that, okay, what are the type of a material we are using. So if we are using the paints with high solar reflective index values, or any other highly reflective materials over the roof to cover at least 50% of the exposed roof area. So provide vegetation. We are having a green roofs nowadays, so we can provide some vegetation to cover so that giving cooling effect on the heat. So then parking facilities, they will be located within the site to minimize the disturbance of the house near to the road. So basically we are looking an area which is again having a proper parking facilities in that thing. And then if it is a site near to the area where non-fossil fuel vehicles are being used, it is again an added advantages, and that is what we are looking for a particular sites in and around during the site selection also. Then another area is we are looking for the physically handicapped challenged people, some sort of this thing. Then going for the next the parameter next component is the water efficiency. As you see that buildings are again one of the major users of water. Our water requirement is, I think you can see that if we go as per the codal requirement, we need about 135 liters per head per day, and in our say urban areas, and nowadays demand is about 250 to 300 liters per day per head in a good city. When we are talking about the smart cities and other good facilities, so water demand is very high, and maybe we need to have our buildings which are self-sufficient in the water. So we need to adopt those technologies in a building. So that is what, okay, we need to use a raw water as far as possible, because you see that, okay, for our most of the needs we don't require treated water is required for drinking mostly, and raw water which can be used for other for your other needs like your irrigation or your flushing tanks or your other this thing. So basically that water where we don't require the treated water there. So that means that okay, we have to use the raw water in different use of the building. So that is a very important. And basically for that purpose, a building what requires that okay, we have to provide the separate plumbing lines for treated and raw water. That is the one advantage. The raw water can be sourced either by recycling the wastewater or by harvesting the rainwater. So you have either some treatment plant which in your located near to your building or near building to your and then that through that tertiary treated water that can be recycled. That water can be reused for your irrigation needs in the building or for your flushing needs in the building. And maybe we can store the rainwater also, and that rainwater water again we can be used for our various other needs apart from the drinking water needs. Then you have the water efficient fixtures, and those water efficient fixture means that okay, we are having we are installing those fixtures where wastage of water is lowest. Like you have the say this sensor controlled say taps where where whenever you require you bring your hands close to that tap, so basically they will water will come for 1 or 2 minutes and then automatically it will stop. So those sort of fixtures we are looking for saying. So these fixtures are available with high efficiency which can reduce substantial quantity of the water consumption in a building. Then use low controlled flow water fixtures for basins, urinals and toilets. Like we are use our cisterns. Instead of using say large capacity cisterns, we need to provide the low capacity cisterns for our toilets and all that. Then flushing cisterns and then install the composting toilets. Then use aeration on all the taps. Use recirculation system for centralized hot water distribution. Like you have the this is the example of dry and water urinals. Basically these urinals have a some sort of a silicon based film inserted inside the urinals that are practically frictionless, allowing for no urine stains or odors in that particular thing. And whenever the waste is there, that passes through a floating cartridge which is filled with an oil like substance which absorbs the fluid and fights the bacteria, and the cartridge is again recyclable. The life of the cartridge is about 5 to 6 years, and it saves about 6 to 10 liters of water per flush. Okay, this is the item of a waterless urinal. So this is sort of a drain, so water passes through. This is the cartridge, and through that cartridge it will passes. And then you have a composting toilets. So it is a one which is not connected to your sewage system. It is a self-sustained site of a system where a degradation takes place inside that inside the area provided through your in the system, and then it it is again conserves a lot of water because you don't require the water for flushing and all that. And whenever the after the some time the manure can this waste can be used as a manure for fertilizing the home gardens. Then the rainwater harvesting system. So basically this can be either to store the rainwater or to enhance the groundwater table. These are the two techniques which can be adopted, and nowadays I think in many of the buildings the government has made compulsory to go for rainwater harvesting system. So whenever where is there, either we provide some storage storage tank to store the rainwater and reuse and use it for irrigation or from for some flushing purposes, and otherwise it can be a system which is basically enhancing the groundwater storage capacity. Then again you have some grey water treatment system, basically which is again adopted to reduce the consumption of water by in situ treatment of grey water generated so as not to pollute the municipal systems and to reduce the consumption of fresh water. So that means that okay, if we are having a in-house treatment facility for a building, so we are not adding load to the municipal treatment plant, and again, and that means indirectly lot of energy is being used to operate that treatment plant, and that energy basically consumption gets reduced in to the extent. So basically whenever we can provide the facility to have a grey water treatment system at the site, so we need to use that particular system into this thing. So that is a one. Then plumbing systems for the flushings. Okay, we provide a separate plumbing system to encourage the use of the treated grey water. So whenever whatever water we are using, so you have a separate system for that, and that means that okay, you are all the secondary needs are met through this tertiary treated water. Then effective landscaping techniques. Okay, you need to practice water effective landscaping technique to save the water. Like you need to plant the basically if the climate is dry, so there you need to plant those sort of plants which require lesser amount of water. Then reduce stormwater runoff by using pervious concrete pavements and PCC tiles with grass borders. Nowadays there are a lot of practices there. Okay, you make the this paver blocks are installed basically which make the surface impervious, and because of whenever the water is there, that flows quickly to your storms and all that. So basically we need to have those sort of system. In material you will find that okay, we have instead of using the paver blocks, you will find that you have a sort of a porous concrete through which the water can seep through very easily. So those sort of techniques are required to be adopted in case of buildings. Then we need to use a drip irrigation and self-closing nozzle in houses for the gardening. Use raw water or recycled water for the gardening, and use a composting and mulches for your produced at the in your building only for the for your plants and all that. Then we have to manage the irrigation of system for the water. So basically irrigation demand is to be met through water efficient management techniques, and for that we may have to provide some metering system and some sort of a valves or sensor controlled valves which okay knows okay when to go for irrigation, when to provide the irrigation. Those sort of things are to be adopted in a building. You see that what we are discussing here, many of the things may be required at some time when we were discussing the rating system. So you will find that okay, it may not be important to achieve all these things, but yes, if we are going for a highly rated, means is a building having either 5-star rating system or a platinum rating system, then all those systems have to be adopted. And there are certain buildings which we will be discussing through case studies afterwards, that yes, they have adopted all those management practices into your so at least 50% of landscape planting bed should have drip irrigation system to reduce the evaporation. And these are the points basically when we are say evaluating a building, when a rating is being done. So all these points, they carry the marks into your system. So so that means if you have a 50% landscape planting beds which are basically having the drip irrigation system, you will be earning few points for your to get the higher rating to your building. So similarly, if you are installed time-based control for the walls such that evaporation loss is minimum and plant health is ensured, that means you are getting an additional point for your thing. Use pressure regulating devices to maintain optimal pressure, and then any other system which we go for watering or you metering, etc. So for that is adopted. So that is again one of the this thing. So this is regarding the water efficiency. That means first we have gone for your site selection. So site is selected where we are taking care of all the aspects of our surroundings and all that, and then we are going. We have seen that okay, we want to use the water in a very efficient way. So we have to adopt the systems where we are reducing the use of water in a building. And another important aspect is the energy efficiency. We started that okay, in buildings the energy consumption, total energy consumption is to the extent of 40 to 43%, and buildings in such as such uses about 30% of the energy requirement, total energy requirement, which are there. So energy efficiency is one of the major criteria which is to which is to be has to be there if we are going for a green building construction. We can say that okay, the first thing is use of the energy efficient lighting systems. You have got LED lights, you have got nowadays say energy efficient other features like lighting or your fans or your refrigerators or your ACs, etc. So there we are using that. That means that okay, we require the refrigerants used in heating, ventilation, irrigation equipment and air conditioning installed must be CFC free, chlorofluorocarbon free. Energy performance should be such that okay, we whenever we are using, that means this is to be considered in a holistic approach so as to include the building orientation. That means we are using maximum taking advantage of maximum lighting, daylighting. Then we are providing envelope in a way that okay, whenever we are requiring to control the say sun from coming into the building, that means we are providing some shading devices, and you have to see that okay, in what climate zones you are there. So either what to projections to what extent they are to be basically whether to how much sun energy you want to enter, how much sunlight you want to enter, so that they have to be basically based on that. So that means whenever we are talking about the various building say projections or your fins and all that, so they have to be based on your in which climate zone you are located and what time you want to your light should enter into the building and when it should not enter. So we have then again at the same we have to identify the materials and equipment available in the market and their energy efficiency, how they are performing. Like if you are having some fans, the the normal fan consumes about say 75 watts of energy, but do you have energy efficient fans which basically will consume about 20 watts of energy. So there is a huge difference in your this thing. And so basically we have to see that with respect to materials, it is not the initial cost but their operating cost is most important. So we have to find out the applications where automatic controls can help in energy savings. Like we are talking about smart cities and smart houses. So basically if you enter in a building, automatically your lighting should be there, and whenever you leave the house, all the lights should be shut off automatically. So that sort of a systems we are looking for into our buildings. And then I think metering is one of the advantages where we are looking which can control the users of building in energy in a building, and basically we need to develop a system which compare the predictive savings to the actual energy performance. So basically if we are able to show to a resident okay what is the how much energy is being served, that is one of the features which is required. So there are the various appliances which have been used to monitor the a building in a house. So so use energy efficient appliances. So all the cool and frost free refrigerator installed must be rated at least 3-star energy. List of refrigerators rated by BA can be referred, and use the right qualified energy efficient appliances. And if you are using old one, they are to be sent to for the recycling purposes. You have a you can say why not to have a washing machine which doesn't require water at all to your this thing. Why not to have that sort of a system? So basically that means we are looking sort of a systems which uses lesser amount of resources. So they have to be energy efficient, they have to be water efficient. And then solar water heating systems. So I think need not go into this thing, but yes, encourage use of solar energy for water heating appliances in a building. Earlier the government was giving a lot of subsidy for that, but I think now the subsidy is not there, but there are indirect benefit. Always the benefit is always there, because in our country the lot of sun is available, sunlight is available, and during most part of the year, I think 9 months we are getting good 9 to 8 to 9 months we are getting good energy light from the sun, and that is to be used for the water heating system. So basically we can have a depending upon our requirement, we have to install the either 100 liter or 200 liter or 300 liter capacity water heating system in the buildings. Then install the solar photovoltaic power systems, because in your non-conventional sources of energy, when we want to use sun energy for generating the electricity, so I think these photovoltaics are one of the major system. Power system is one of the major system which goes into, and all the buildings, I think most of the buildings which are having a particular area, they have to go for this thing. And under this smart city mission, I think using the sun energy for generating your electricity is one of the major requirement. Wherever we are having this thing, or we are having Chandigarh has been declared as a solar city, one of the city maybe under solar mission. It will be the one city which will be generating its own this thing. And let me say that our even the target in our NITTTR, we have decided that okay, whatever our energy we are utilizing, about maybe about 25% of the energy our requirement will be met through this solar energy only. So we have already installed about 50 kilowatt of this photovoltaic or solar energy system into our roofs, and remaining we are going to install, and most probably at the end of the next year our energy up to 25% energy needs will be met through the solar energy only. So we have this again the storage. Whenever we are using the storage, maybe where we are using the say ACs, why not to have a solar panels attached to photovoltaic panel attached to it? So basically the AC are to be used when there is a direct when there is a high temperature is there. That means ACs will run on the solar energy only, and those sort of systems are required to be developed. Solar water heating panels, there are this thing. So you have this the collector system is there, this is a tank is there. I need not go into detail of this thing, okay, what is because we are here discussing what are the systems available this thing. So so we can go for the solar water harvesting system. Then already we have said on-site renewable energy, that okay, yes, we are providing the system, energy system, wind energy, biomass, biogas, etc. are to be utilized for generating the, apart from the solar energy, for generating the electricity at the site or within a building only. So lighting, to encourage use of energy efficient lighting system to reduce the energy consumption within the home. So basically provide the energy efficient lighting, install energy efficient fixtures and all that. Minimize the lighting load by using energy efficient lighting fittings, efficient tubular fluorescent light fittings with electrical blast, dimmers, compact fluorescent lights fittings, and LEDs, etc. Then you have also considered the quality and life of a lamps and evaluate the economic viability. Then use high performance glass for outer envelope of the building. So we have kept a separate session basically on this also, apart from energy this thing. So these are the energy efficient systems. So high performance glass used for glazing in a building not only improves aesthetic appearance but also lowers the energy consumption by 35 to 40% in comparison to the conventional glass. It reduces the ingress of heat and allows higher penetration of the daylight, and typical payback period is varies from 3 to 4 years. Initial cost is high, but yes, your energy. This is a one building, a green building, which is, we can say here the one glass has been, high performance glass has been used, and you can see that energy is entering from light is entering from your this glass and basically providing good sort of a lighting and other to the occupants of this building. So we can provide like other energy saving measures in the this thing. One option is, like if we are having in a multi-story building, you are having this overhead water storage tank. So there we are providing the level controllers. So whenever as you can say, the automatic cutoffs are there. So whenever the pump will restart when the water goes down at a particular level, and those type of systems are to be installed, because if you are using this at a particular time, that means more energy is being utilized in for lifting the water and all that. So basically whatever we are using, so that should be used in a efficiently. Then you have the material efficiency. Yes, during construction you can see that first thing is like there is a lot of waste is being generated. So basically, you have to take care of that waste in a building, and uh, you have to provide a common facility for collection of the waste, segregation of the waste. One of the major thing is that okay, we separate the biodegradable and non-biodegradable waste, and then basically you reuse, basically use that particular material in a that way in which it can be used. So basically we can have a sort of a facilities where we can organic waste, where you can paper and cardboard, where we can plastics, where we can metals, and where we have the e-waste and battery, etc. Because again, this e-waste is one of the major things in our nowadays, and so we have to properly segregate the waste into a system. So that is what. Then second option is, second thing is okay, waste reduction during construction. Even during construction also, whatever the waste is being generated, that is to be reutilized. If we were throwing any brick beds or any cement or any sand or any aggregates, etc. So basically all the debris in your residential projects, they could be broken into bricks, steel bars, broken tiles, glass, wood waste, paint cans, cement bags, packing material, etc. So we have to look into this thing, how that waste is being reused into different activities during construction itself also. Then solid waste management. After occupancy, we have to ensure the effective solid waste management in the building, and for that you have to either provide the on-site solid waste treatment technology or treating all the organic waste. Then output from such systems like manure, power, etc. should be reused, and typical technologies recognize that digesters, gasifiers, and vermicomposting, etc. is to be basically installed in a building. Then we have to use the materials with recycled content. So that means that okay, either we are using fly ash, recycled content such as fly ash blocks, tiles, steel glass, cement with fly ash, or false ceiling, aluminum and composite wood, etc. So these are all the things which is recyclable or which has been manufactured by using the recycled material. Means that okay, there are two components. One basically which is made from the recycled material, or other is which is recyclable. So after we are using it, so that is the one thing we are looking into the material efficiency of a particular one. So you can see that fly ash is again a fine glass like powder recovered from gases created by coal fired electrical power generation. So it is an inexpensive replacement for Portland cement used in a concrete. I think nowadays that if you go to the market, you can't get a cement without fly ash. Yes, if you want, you have to get it specially ordered from the company. So but using a fly ash in the cement, it improves the strength, it improves your segregation and ease of pumping of the concrete. So it is easy to use that particular thing. Fly ash is also used as an ingredient in bricks, blocks, paver blocks, and other structure fields. Even so, fly ash is environment friendly because it can be recycled and has low embodied energy, because no energy is being utilized for its manufacturing processing. So that is what we are looking for, a material. So this is the one, fly ash bricks or fly ash based concrete blocks which can be used in a construction of building. Then recycled content like ceramic tiles are underutilized, or because they have a high density, high durability, and they have a good thermal storage capacity, and so high density limits moisture absorption and creates a temperature resistant surface ideal for both wet and dry surfaces. So wherever we are to use this ceramic tiles, I think they have basically, they can be used. In addition, recycled content tiles are also good for passive solar design in climates such as ours with warm days and cool nights. If you provide the say rooftop with a waste white recycled glaze tiles, so it will prevent the heating of your roof, and it acts as a insulating material. So many companies make ceramic based tile of 70% waste glass collected from light bulb manufacture and from recycled automobile. The glass is ground down and mixed with ceramic base, and no pigment is added. Pigment is added to create designer like things into that this thing, so that you can get a good product which is having a which is as comparable as compared to your Italian tiles. So these tiles can be utilized to create and match traditional designs and patterns found in many houses. You can see this is the one example of recycled glass tiles which have been used in the roof at this thing. Again, this is again the porcelain tiles which have been used in the roof. Natural terracotta tiles. Again, it is made from a recyclable material. Then steel is the one material which is a recyclable material, and it is recycling capacity is very high. You can say 50%, 55% of the steel made comes from the recycled steel only, and producing steel from the recycled material saves 75% of the energy needed if steel were made from the virgin material. You see that, okay, one example is, okay, that that when twin towers they came down, so whatever because they were made from steel, whatever the steel was there in this thing, that was recycled in Punjab only near Fagwada. So most probably, yes, it has got a lot of a recyclable value. So we have to look into sustainable design and a building created with steel joints and other steel structure components, so that it is a recyclable value is high. So this is one, the recyclable steel. You can say this is the one particular building in Germany. You can say it is entirely constructed from recyclable steel only. Aluminium is the one particular material again, which is again recyclable. Aluminum is 100% recyclable. To produce aluminium from recycled material, it requires only 5% of the energy required to produce aluminium for bauxite ore. That means 5% of the total energy which is otherwise used for making it this thing. So every ton of recycled aluminium saves about 4 tons of bauxite. You can see that how much saving is there. So additionally, using recycled aluminium instead of raw material reduces air pollution generation also, because we are not and then also reduces the water pollution to an extent. So this is the one tiles made from the recycled material. This is again your aluminum countertops which have been made from the recycled material. So basically we are looking into a building that, okay, into this thing. So materials, various materials which are recyclable, such as bamboo, wool, cotton insulation, agri fiber, linoleum, wheat board, straw board, and cork, etc. So during construction, ensure that these are the materials which are having the renewable capacity, so they are used in our building construction, building activity. Recycled wood can be used effectively for cabinets, trim, doors, shelvings, and window frames. Reclaimed plumbing is often higher quality than the newer lumber and grasses such as bamboo and straw. So you can see that MDF board we are using in our buildings is the one. Then bamboo can be harvested in 3 to 5 years, and basically we can say MDF boards derived from is a renewable product. When it's come to flooring, cork, bamboo, and linoleum, this the floor is one which is very useful one. This is a kitchen made from the bamboo product. Cork is again a renewable resource, and that is harvested from the bark of a tree every 9 years, causing no damage to the tree. It is durable, lightweight, and has less low density. Then cork flooring offers a very long life and is easily repairable. The air compressed in the millions of cork gives a very cushioned feeling under the foot. It offers a great relief when you walk on this thing. So it is a useful. Basically, it can be used as a sound insulation material also. It is a good great heat insulator, and it makes the basically if a cork is present, it makes it termite free also. Even if the floor is submerged in water for a long period, the substance prevents it from rotting also. So it is a natural fire inhibitor. So this is the one material. So this is the cork flooring. You can say it gives a good. Then agriculture fibers, agri fibers. I think you see that there is a lot of problem when we have to burn them: wheat straw, rice straw, bagasse, and grass straw, etc. So if you throw them as a waste, from where to throw them? But they are a good source of a material which can be used for making the your MDF boards. They can be made. They can be you can make some structural components, panels, molded products, medium density fireboard, etc., using the grass straw, cereal straw, or the rice straw, or bagasse based into your this thing. So those fibers, so agri fibers made from these products are to be used in a building. So these are the agri fiber panels you can see. Nowadays we are using a lot of these type of products in our finishing this thing. Linoleum is an all natural product made of linseed oil, pigments, and pine flour, and it is made from the nature materials. It offers a healthier indoor environment. It has no adverse effect on the health. Bacterial properties of the natural linoleum is again it stops microorganisms from for multiplication. In addition to health benefits, the flooring provided using linoleum is the anti-static. It reduces the potential for electric shock. It also makes the floor easier to clean. It makes it dust and dirt free also, and though it is not in fashion, but it is a very durable, water resistant, and easy to use the material. Okay. This is one you can say how aesthetically by using different color you can give a good finish, and again aesthetically it looks very good. Then use of the local materials available. One of the major requirement under this thing is that whatever the users ensure at least 50% of the total building materials by cost used in the building should have been manufactured within a radius of 500 kilometers. You can see that in countries where these thermal plants are there within the radius of 100 kilometers, you are not to use the clay bricks. You have to use the bricks manufactured through fly ash only. So reuse of the salvage materials. So that is what we have to use that. At least 5% of the total building materials by cost used in the building is from salvage material. Identify opportunities to incorporate these materials into the building design and such potential material suppliers. Consider salvage materials such as flooring, paneling, doors, frames, furniture, bricks, etc. I think you can see our this thing also. Recently we have got our houses all renovated, and if you come to this our one of the grounds, it is fully occupied by, you can say, the doors, windows, and other material. Now how to use it is basically that is one of the measures. So I think if you are this is the one point basically which fetches you additional this thing in while getting your building rated. So whether you have used the salvage material into the construction or not. So then wood based material. So minimize the use of virgin wood, thereby encouraging responsible forest management practice. So use of wood based applications in the home. Use recycled wood for furniture and flooring. Substitute the use of virgin wood with forest steward with Council of Forest Department certified wood at least by 50%. So this is the one we can recommend wood furniture. This is the one basically the made from the recycled wood only. So this is on material efficiency. Then the last point you are having is the indoor air quality. Good ventilation is very important. So because it is a good for the health of the occupants. So that means we have to design our system. So whatever the fresh air should enter into the house, and all the polluted air should go out from the house. So that means that we have to design the exhaust systems from the bathrooms and the wash kitchens. Then basically it is not important to install the exhaust fans, but sizing of these systems to throw out the gases is very important. So have a fresh air ventilation system. So avoid indoor pollutants affecting indoor air quality by providing adequate outdoor air ventilation. So and have a good air conditioned space. Design a ventilation system for air conditioned spaces to meet a requirement of 60 cubic feet per minute per person for each air conditioned space. So this is the basically based on that we have to divide how many occupants are there. So at least we have to take care of that system. Even in non-air conditioned areas, we have to see that all naturally ventilated, regularly occupied spaces shall be within the 4.5 meter of the openable windows or doors, and openable areas must be at least 15% of the carpet area in a building. For kitchens and bathrooms, provide openable areas which is equal to or more than 10% of the carpet area. then approach would be to have large openings on at least 2 different directions so as to allow the cross ventilation. It is again very important. So that means when you are considering the building envelope or designing this thing, so these aspects are to be considered into your listing. Then use of low VOC material. Basically that you materials which volatile organic content are there, so you have to reduce use of those materials. So use paints with low or no VOC content to the extent of 100% of interior wall surface area. And for other VOC emitting materials, the use should be it should be such that within interiors that VOC content does not exceed the limits as specified by the various standards. VOC means that where we are using this benzene, formaldehydes and toluenes which are added to the solvent to help the paint dry and cure faster. So when VOCs evaporate, they contribute to the formation of smoke and are responsible for the objectionable and easily recognizable new paint smell. ठीक है, कहीं आप नया पेंट देख रहे हैं तो you will find that एक peculiar सी smell आती है, and it can be potentially harmful to the individuals with certain allergies and other conditions. So low level exposure to VOC can cause temporary health problems including headaches, dizziness and nausea. So we have to take care of these things in the building. So higher exposure levels can cause permanent damage to kidneys, liver and nervous system and nervous repressive systems. Plus outgassing from the VOCs contributes greatly to indoor air pollution and outdoor smoke whenever its emissions are react with the other hydrocarbons like nitrogen oxides and sunlight, etc. So high levels of VOC paints can be avoided by choosing latex based products. In latex paints, water is the primary solvent. So we are not using the chemicals as a solvent, but we should be looking for materials which are using water as the solvent. Okay? Then we should carpets. So to encourage use of carpets with low emissions so as to reduce adverse impacts of the building components. So use carpets made of naturally available materials like coir, wool, etc. for 5% of the carpet area. In many places, carpets used for mock-track are made for naturally available materials which do not require any adhesive while installing. The sealants and adhesive used for gluing carpet should be having low VOC. So these are the from certified overseas. So, building flushover means avoid occupants' exposure to indoor airborne contaminants before occupying the premises. So, if building is occupied and after the paints, adhesives and sealants have been used, a building flush out needs to be carried out for 10 days by keeping all the windows open. Or if the building prefers to carry out the flush out using forced ventilation system, the flush out can be carried out for 5 days. Daylighting. So ensure the connectivity between the interior and the exterior environment by providing good daylighting. So we have to fenestrations. These fenestrations you have to properly design and provide in a way while designing the building envelope. Okay. So proper orientation. So orientation means that maximum daylighting to all the spaces is achieved for most part of the day, and minimum average daylight factor is ensured for the building units. Okay. Average daylight can be calculated using daylight factor formula like window area by floor area into window geometry into actual visible transmittance and minimum visible transmittance into the height factor. So achieve a minimum average daylight factor of 2% for at least 75% of the total floor area of all the regularly occupied spaces, which include kitchens, living rooms, and so that means that okay, we are looking that whatever the daylight is entered, that means we're at least 2% daylight enters into a 75% of the total area, so that you have good ventilation and good daylighting into your house. So these are the just shading devices, basically window type into which type of a system, what is the height. So depending upon that we have to see this is a side lighting, daylighting glazing. Okay, this is the vertical monitor system. This is the top lighting. If you are from the roof, you are constructing this thing. If this is again the top lighting into your this thing, and this is the horizontal skylights is to be provided. So depending upon the location where you are located, so you have to go. If you are in an area where direct sunlight is not required, that means you are providing the side lighting. If you are having some lighting is there, so vertical top lighting is required. If you are having a winter sort of your light should enter from the top into the house. So depending upon your location and your this thing, you have to basically basically provide sort of a system. So these are the say factors, basically geometric factors, which are to be considered. So you need to provide that sort of a system. You provide either interior fins, exterior fins, louvers, fixed fins, depending upon your location and all that in which you are designing your this thing. So cross ventilation is to be ensured. So whatever the cross ventilation means, you have to provide the at many places this aspect is neglected. So indoor air and daylighting aspects are to be considered by providing narrow corridors or to improve the indoor environment as well. To design the building, the distance between each dwelling units meets the criteria. At minimum of 3 meter wall to wall distance between two dwelling units. It may not be possible in because of the building bylaws, but wherever it is possible, we need to have at least 3 meter distance between the two units, and a minimum of 2.4 meters corridor width separating the dwelling units is to be provided into this thing. Then you provide the tobacco smoke control areas. So minimize the exposure of non-smoker to the adverse health impacts to the occupants. So prohibit smoking in common areas and design the building to eliminate the minimized tobacco smoke pollution amongst the dwelling units. So basically where smoking areas should be provided, so signage should be provided, and accordingly this has to be. So effective internal air quality monitoring system are to be provided. So install a permanent CO2 monitoring system that provides feedback on space ventilation performance and specific calibration of all the sensors as per manufacturer guidelines for this purpose. So you have this smoke meter installed at your this thing or use this thing. Now, so these are the 5 criteria. We said that okay, proper site selection is important. Then you have to achieve the water efficiency. You have to achieve the energy efficiency, and then use the recycled and recyclable materials in construction of buildings, and then provide good indoor air quality. Now coming to this thing, what are the perceptions and reality about this thing? A few myths about the buildings. That okay, the first perception is that green buildings are costlier. The reality is the cost could be slightly higher than a conventional building, but the payback periods are very small. The life cycle costs are considerably reduced depending upon the extent of eco-friendly features already considered during the design. So okay, then perception, another perception is green buildings have to be air conditioned. So green building concepts and the LEED rating system can be applied for non-air conditioned buildings. It is not necessary. It has been applied to the buildings which are basically like IGP office in Gulbarga and Hyderabad Institute of Technology and Management. The building is recognized as one of the other energy efficiency measures incorporated, for example, the envelope lighting and roof insulation. It means that okay, it is not necessary that whatever you achieve, basically if you have achieved that particular level of your efficiency, then you are basically eligible to get your building rated as a green building. Then green buildings they take more time for construction. This was the case when the first few green buildings were constructed, but at that time it was not known certification kahan se lena hai and from where to get the certification. But now there is not such thing, and whenever we are basically going for the building, so time schedule for the rating system has been specified, and we can be there are thinking within a few this thing. So construction is again not it doesn't take a longer time. So we are talking about this green building. So what are the different type of rating system for the green buildings? You can see that there is one USGBC LEED rating system, United States green building LEED rating system, Teri Griha rating system, LEED India rating system, then IGBC rating system, Building Research Solution Amount Assessment Method, and US EPA Energy Star system, and NITTTRCHD National Green Building Program. So these are the various type of a rating system: LEED, Griha, and IGBC. IGBC has come up with basically a rating system for different buildings, like if it is an institutional building, if it is an industrial building, if it is a school building, if it is an individual house, or if it is you can say existing existing building basically which you are converting into a green building. So for that they have also provided the different criteria for the rating system. Actually, I don't say different criteria, but criteria for the rating system. And basically, this is all the systems are rating systems are based on the point system. You have to achieve the minimum grades basically for that. Achieve the under are this different rating system like site selection is having say about some points attached to it, either 15, 14, depending upon the type of rating system. Similarly, this energy efficiency, it is having certain points to be achieved. Under that, so leadership and energy and environment design lead green building rating system is the international accepted benchmark for high performance green buildings, and lead promotes a whole building approach to sustainability by recognizing performance in all the 5 key areas which we have discussed, like sustainable site development, water efficiency, energy efficiency, material efficiency, and indoor air quality. This thing. So it is a currently used for commercial institution, high-rise residential and new construction, and for major renovations also. If old building is to be converted into green building, even that can be done. You can apply under lead rating system for that purpose. Okay? To earn lead rating systems projects, you must meet the prerequisite and performance benchmark criteria, and your building will be rated as awarded certified silver, gold, or platinum certified building depending upon number of credits you have achieved. Like if you have achieved a 52 plus point, it is a 59 point scale. If you have at 52 plus points, you get a platinum level for your building. If you are away, but you score between 39 to 51 points, you achieve the gold level. If you achieve 33 to 38 points, you achieve the silver level. If you achieve 26 to 32 points, you achieve the lead certified this thing. So that means under site selection, under your material selection, we have seen that we have discussed the different criteria. So there you may be seeing that okay, it may not be possible to fulfill all the criteria. So that means if you may have installed your water fixture, you may not have installed the tertiary water treatment plant you are building. So accordingly, you carry the point, you achieve the certain level, and you will be awarded accordingly. Either it can be platinum, it can be gold, it can be silver, it can be lead certified building. So there are total 69 points classified for the various component. You can say sustainable sites, you get 14 points. Okay? Water efficiency, about 5 points. Energy and atmospheric, about 17 points. Materials, about 13 points. Indoor air quality, about 15 points. Another 5 points they have kept as a for any innovation. Either a architect or a contractor or a owner has basically provided into construction of that building. So these are the things. So under that sustainable sites, it's like 14 points means first how nearness to your public transport system, it may be carrying 2 points. Then your paved area or unpaved area, it may be carrying 2 points. Then disturbance to your natural topography, it is carrying some points. So all those points they add up to the 40 points. So it may be that okay, under site selection you may not be achieved the 14 full points, but you may be able to achieve the 10 points. Similarly, water efficiency, you may not be able to achieve the 5 points, you will be achieving 2-3 points. Energy efficiency, you can achieve 13, 14, 15, whatever the points. So total of you must be basically, as I said in your previous slide, in whatever level you go, you will be given the certification accordingly. Okay. Then you have the Terry Griha rating system. These are the green building rating that evaluates the energy efficiency of a particular building, and basically again it is based on the same 5 criteria like your site selection, material efficiency, energy efficiency, and this thing. So it is a and different practices are there. So it is also a input from the voluntary building codes, guidelines being developed by the Bureau of Energy Efficiency, the minimum of non-conventional source of energy. Basically it is an Indian system which हमने developed in the Griha rating system, in the Indian system. तो इसमें जितने भी थे the EIA के requirements, your जो आपका इम्पैक्ट एनवायरमेंट इम्पैक्ट एनालिसिस करते हैं उसमें बिल्डिंग प्रोजेक्ट्स की रिक्वायरमेंट प्लस यूर MNRE के रिक्वायरमेंट प्लस यूर वाटर के रिक्वायरमेंट, सो उन सबको इकट्ठा करके दे हैव बीन पुट टुगेदर एंड दोस rating has been given defined as the Griha rating system, and it is a 100-point system. Okay, and that different level of certification are 1 star to 5 star. They are awarded based on the number of points earned. The minimum points required for certification is 50. The building scoring 50 to 60 points, 61 to 70 points, 71 to 80 points, 81 to 90 points will get 1 star, 2 star, 3 star and 4 star respectively. The building scoring 91 to 100 points will get the maximum rating, that is the 5 stars. Then you have the IGBC green homes rating system. So IGBC first started for individual houses. Okay? And so the first rating program developed in India exclusively for the residential sector. It is based on the accepted energy and environment principles and strikes a balance between known established practices and emerging concepts. The system is designed to be comprehensive in scope yet simple in operation. Okay? The IGBC rating system has been developed based on the materials and technologies that are presently available. The rating system evaluates certain credit points using a prescriptive approach and other credits on a performance-based approach. The rating program uses well-accepted national standards and whatever the other local and other standards are there. Similarly, but basically in the Griha was there, so they have been incorporated by the IGBC also. And basically they have the system like certified to recognize best practice minimum level, silver to recognize outstanding performance, gold to recognize national excellence, and platinum to recognize the global leadership. So they have the these four system into your this thing. And for the individual houses, certification level is certified if you score between 30 to 39 points, silver 40 to 46 points, gold 47 to 54 points, and platinum 55 to 79 points. It is a 79 rating system program. And for multi-dwelling units like multi-story buildings, the certification level point is 30 to 37, silver 30 to 44, gold 41, and 53 to 75. Yeah. So coming to your this aspect, green building in India, we will be discussing about an overview. So you can see that lot of growth is taking place in India in the infrastructure and construction sector. The construction industry in India, as I said, is growing at a rate of 9.5%. As the sector is growing very rapidly, so there are many opportunities available, and they are basically we have to take care of those opportunities, and we have to see that okay, we meet the minimum environmental standards while going into construction of a building. And you can see this is already I have explained. So IGBC, which was established in 2001, already they have, though this is ICCI Sobraj Godrej Building Business Center has been established, the Indian Building Green Building Council. Our institute is member, they have got one chapter, basically there is student chapter of IGBC in our institute also. So it is a non-profitable council representing the building industry, consisting of more than 350 committed members, and council encourages builders, developers and owners to build green to enhance the economic and environment friendly buildings. And this is the one Turbo Energy Limited, the greenest building in India. It is in Chennai and has the US GPC Prestigious LEED Platinum rating. The building achieved 60 points out of the total available 69 credit points, the highest credit points achieved so far in India. The built-up area of building is about 37,000 square feet area. The salient feature of this building is solar powered air conditioned with solar parabolic. सोलर सन के साथ पाथ के साथ साथ उनका जो फोटोवोल्टिक्स प्रोडक्ट है, दे मूव विद दैट ओनली. ठीक है. डिशेस विद द एबिलिटी टू ट्रैक सन पाथ, फर्स्ट ऑफ इट्स काइंड इन इंडिया. 70% of the energy saving over ASHRAE 19.1 2000 standard. 25% of the building energy consumption through renewable energy sources, and zero water discharge site. No water is being discharged at all. Whatever the water is being used, it is being reutilized. More than 70% of the space is having good daylighting system. So these are the salient feature of this particular building. Then you have a CIA building in Hyderabad, which is again the first IGBC building, the green building in India, the first platinum rating building outside US, first platinum building in the world under version LEED 2.0, and the CIA Godrej building has achieved 56 points out of 59 points attempted, and it is designed by an Indian architect, Karan Grover of Karan Grover and Associates, Baroda. And it is again one ITC green building at center in the Gurgaon. It has been awarded platinum rating by the US Green Building Council LEED. It is certified first corporate house in India to bag the prestigious award. Then Grundfos Pumps in Chennai, they have basically again have been awarded the leader in the building, has achieved 42 points out of 16 points possible and is the first gold rating building in India. The office complex is constructed on 2-acre plot of land with a built up area of about 35,000 square feet. Wipro building in Gujarat is the center in India, which is located in 1.12 hectare, about 1,75,000 square feet of area, which are the individuals basically occupied the building of 1,000, 3,005 occupants are there. So it has achieved all the 57 points attempted and has been awarded the prestigious platinum rating by US Green Building Council. It is designed by Indian architect by Mr. Vidur Bhardwaj. This is a skyscraper, you can say, in Mumbai, Mukesh Ambani's house. It is again one building which is a 27-story building located, owned by the Reliance Industry, biggest in the private sector. It is again having the living walls enclosing all the 4 sides, hanging garden and a green rooftop in the vicinity. Then you have the Dubai Tech, largest green building in Dubai. This is a twin building. Okay. It is a LEED certified building, which is basically promotes the excellence for biotechnology, education and research. 2 connected buildings having a maximum daylighting and views while minimizing the solar gain. It also integrates a 5,00,000 square feet animal reserve for the indigenous conservation and wildlife protection. Then you have the sky farms. Basically, what the new areas basically in which we are looking for is the skyscrapers. Basically, one where you have, because you can say your agricultural land is shrinking. Okay. And there also, so we are vertical buildings are being designed, which will be basically very near to the urban farms. So this is the one, you can say, type of a building. This thing, you can grow various vegetables or other your needs of your food needs can be met through construction of these high-rise buildings only. Okay, this is the one building. So vertical farm building designed to incorporate various green building strategies in a mixed-use residential commercial building complex. The structure is designed as a kind of built organism, basically which is completely self-sufficient and adapted to the surrounding. The design includes water energy self-sufficiency from rainwater and grey water collection, reuse, solar cells, vegetable and grain growing spaces, and even a chicken farm also. So these are the sort of a buildings basically which you are looking for this thing. This is again showing the night view of that particular this thing. Again, the different buildings are there. I think, yeah. So this is a one Columbia University professor. He has designed these farmhouses, and these towers have been built basically to produce more energy and water via condensation and purification and food, and encourage the occupants to use them also. This is the one particular building you can say. Okay, this is a skyscraper farm. So this have been conducted to build the feed tons or thousands of people per year, because otherwise land area is shrinking. Now I think we are another concept which is picking up is the concept of the green cities. We can say the because now we are talking about in India about the smart cities. Green city is one component of that smart city. We can say. Until unless we make a city green, we cannot make the city we cannot compete for the smart city otherwise also. So one particular city which is a green city is the Mustard City in Abu Dhabi. It is in United Arab Emirates. It is an initiative by the government of Abu Dhabi. It is designed by the British architect, and which is based on that particular thing, that the city will rely entirely on solar energy and other renewable energy sources, with a sustainable, zero carbon, zero waste ecology. No waste will be there, no water will be there, and all the energy which is emitting will be met through by your solar energy only. The city is being constructed 70 kilometers east south of the city of the Abu Dhabi, besides Abu Dhabi, near to the Abu Dhabi International Airport. It has been initiated in year 2006. It will employ various renewable power sources, 40 to 60 megawatt solar power plant. Photovoltaic modulars will be placed on the rooftops. Wind farms will be established outside the city perimeter. A solar power desalination plant will be installed to use the water. 80% of the water used will be recycled and wastewater will be reused as many times as possible, within this grey water being used for the crop irrigation or other purposes. Biological waste will be used to create nutrient rich soil and fertilizer, and some may also include the utilized through waste incineration as an additional power source. Means whatever the biological waste is there, either we can utilize as a fertilizer or it can be used for power generation also. Industrial waste such as plastics and metals will be recycled or repurposed for other uses also. So whatever that means, no waste will be generated. Whatever the waste is being generated, it is being recycled for this purpose. Automobiles will be completely banned within the city. Travel will be accomplished by public mass transport and personal rapid transport system, with existing road and railway connecting to the other location outside the city. City will be walled to keep the hot desert wind away from it. The lack of cars will allow for narrow shaded trees that will also funnel breeze from the one side of the city to the other side also. So narrow streets प्रोवाइड करें ताकि जो एयर फ्लो है उसमें सन ना आए, उनको रोकेंगे, एंड ब्रीज कूल ब्रीज is able to flow through the streets. So it will be cooling the your houses also. So basically that is what we are looking for into our green buildings and green cities. So the thing is that okay, we should adopt green to save the environment and look into the that is what I say, that is a very important topic of green buildings, because once we are saying that okay, we are to make our city smart, so one component of smart city is the green buildings in that particular city. So with that I think we will close down. Thank you very much for your patience hearing, and maybe any questions or anything. Yeah. Yeah. Any maybe we can go one by one. Yes. This is the center. This
Yes, from Bandi University.
yeah.
Sir, any queries at your center? Bandi University?
No questions, sir.
Okay, sir.
Okay, we.
Indus Institute?
Hello.
Yeah.
Indus Institute.
Yeah, please.
Sir, which type of rating system is used for campus academic buildings and this type?
Yes, we have a because you see that we have a different rating system available in our country. One is the GRIHA, one is the IGBC rating system, and through that for these either for institutional building, for a usual house building, or for a commercial building, or for an industrial building, or for an existing building if we are converting into a green building. So different criteria are there, different though basic components of that like your proper site selection, energy efficiency, water efficiency, it has to be there, but little bit difference about maybe there, but mostly the criteria is same for all these buildings also. So you can adopt any, because once you basically make your building, convert your building into a green building, you will invite the auditors through IGBC or through GRIHA this thing, so they will come and they will see that okay, under these different heads what are the components that has been incorporated into your building, and based on that you will be getting the points. Like if you go for say your accreditation like NBA, if you are going, so you have different points under that different components. So similarly in GRIHA in your rating system also you have to earn the different points, and based on that you will be given the your either certified or platinum 1-star 2-star rating system. Yes, I think.
Yes, sir. Any other question?
So we will be having a detailed discussion on these different aspects also. Like we have a one detailed session on water efficiency. We have one detailed session on indoor air quality. We have detailed session of your maybe energy. We are devoting a lot of time because ECBC code, solar passive design, then high performance glass or materials also. So we have got a separate session also. Yes.
At PVP Siddhartha, any query at your side?
Any queries? PVP
1 minute.
Sir.
Yeah.
Sir, you have mentioned about a high performance glass
Yeah.
in the presentation.
Yeah.
What are the strength properties of the glass, sir?
What is the
What are the strength properties of that glass?
strength properties?
Yes, sir.
Uh, Yes, actually, when we are designing this thing, I think we have to take all the loads and design basically that size and select the proper size of that particular thing. And yeah, so we have to say basically take into all our design aspects, design features, and test basically see the thickness, size, and all those things is to be checked for this designing, and accordingly, yes, we are able to meet all the loads and all the loading criteria which is there for a particular building. They are able to perform in that way. So we have a basically one particular session kept on this high performance glass. For one full session is there, so more detailed discussion will be done in that particular session. There we have invited the experts basically who are into the manufacture and installation of this high performance glass. So they will be coming and discussing more detail about this thing also. But definitely we are taking care of all these design needs into why we are using this glass into our buildings.
Okay, sir. Thank you, sir.
ठीक है. In the global.
Any query from you? Would you like to give any feedback?
Okay, we can go ahead. Next. Okay. So thank you very much, and we will be assembling here. Not 3 o'clock. I think 2:15. Because we will like to start session by between 2:15 to 2:30. By 2:30 we will be I think we should start the session at least by 2:30. So most probably I will request all of you to be here by 2:15.
4,000 ज्यादा हो गया, कितना खर्च हो जाएगा? हाँ, बता रहा है 4,000 करने
लेयर कहाँ पे ऊपर ही?
हाँ दोनों लालमन वाले लेते हैं।
लालमन ये ले चलते होना चाहिए।
हाँ तब तक तो फिनिश कर दो। नहीं दिखता। इसको लगा ही लेते हैं तभी नहीं। Should we start? Huh? Okay. Okay, good afternoon to all the centers. I welcome you all to the post-lunch session for day 1. There's a little change from the schedule. The rating system that will be discussed on Thursdays now. So we have taken up a topic to talk about the carbon footprint with all these buildings and everything, since we are talking of green buildings. So construction industry is what we have already understood is a major contributor to this carbon footprint. So I'll be talking about various measures that this construction industry can take up to reduce their carbon footprint. I hope all the centers are connected and they can hear us well. Should I go ahead? Yeah. All right. So basically now starting, I think the importance has already been highlighted by Dr. Sharma in the morning. So we really need to understand that what we inherited, we have to let our children inherit the same. So that will be the earth, the air, the land, the water. So they are not an inheritance from our forefathers, but they are a loan. They are a loan for our children. So we have to hand over to them at least as it was handed over to us. So that is a very famous saying by Mahatma Gandhi. So this importance of this topic was well understood time before also. So that is what we need to give our children, the same earth, the air, the land, the water. So we really don't want a scenario of what we can see below in the below pictures. So talking about the various environment problems that we are facing, and we'll just slowly see how they're connected to all this construction industry and all the building sector that has come up with the globalization and industrialization. So the various environmental problems that we are facing, one is global warming. What exactly is global warming? Basically, it is the level of carbon dioxide in the atmosphere, which is the highest in the last 750,000 years. So the 22 warmest year ever recorded have occurred since 1980. This is a direct result of greenhouse gas emission. So over 2,500 of the world's leading scientists collectively agree that this is the major contributing factor, and this has to be addressed in a wide scale manner. So if we continue to live the way we are, so we will need another 5 planets to exist. That is what is estimated. So actually we have actually outgrown the resources of the earth, the way we are actually living and way we are multiplying our needs and resources needs. So earth is actually not enough for us now. Okay, so these are some of the issues that have come up, which are actually a problem of what the environmental problems are there. So these are all a result of that. A firestorm which flows through Colorado. So these are increased incidents of wildfires. This is a result of climate change. So we can see a little fire in the forest that can actually aggravate to big levels, and these incidents are actually increasing because of climate change. Okay, if we talk of the planet, we have shrunken the forest. The deserts are expanding, the water tables are falling, the soils are eroding, and the temperatures are rising, and the seas are becoming more and more hostile for the mankind and the other living beings on this earth. Even the natural disasters, they have increased more than 4 times over the last 40 years. The windstorms, they have almost increased 5 times, flooding 6 times, and bushfires almost tenfold. I guess needless to say, the reason I'm actually stressing on these numbers is so that we actually, even sitting there, we should understand that this problem really needs to be addressed now. Okay, so this is a picture of a 1,000-year-old forest which actually fell victim to the chainsaw for a new dam. So there was a new dam construction that was planned, and this is what was done to a forest which was almost 1,000 years old. Okay, so most of the rainforest, they have been reduced to barren lands now. Now, if I talk of the water and glaciers, 96% of the glaciers are currently diminishing in size. So most of the glaciers, they are actually diminishing in size. By 2030, 2/3 of the glaciers might perish. 300 million Chinese rely on water for irrigation. Over 1 billion people are already suffering from shortage of clean drinking water, a big problem. Clean drinking water is not available now to the population. So when the glaciers would be gone, there will be no irrigation for the whole of Asia, putting the whole world in a net food deficit, a major catastrophe. So we need to understand if the glaciers are gone, Asia will face a major irrigation issue, and that will actually affect the entire world in terms of the food that is being exported from Asia to the entire world. So there will be a food shortage actually connected to this problem then. Okay. This is another picture showing paradise which was almost lost, the Maldives, a popular vacation spot that is now threatened by rising sea levels. This is what Maldives is facing right now. Now this is a massive waterfall from melting pack ice. So these masses are the only melt water on earth and the undeniable proof of how swiftly climate change is advancing. So we can see what is happening to the ice packs now. Now if I talk of the habitat, our planet, it is also a habitat for many species, flora, fauna. So 15% of all plants and animals are right now threatened for extinction. We have to understand they're getting extinct. 12% of birds, 20% of reptiles, 23% mammals, 31% of amphibians, and 40% of the fish. And we all understand that the way this globe works, there are ecosystems, so there is a balance for, and each and every inhabitant, each and every organism plays a role in it. So humans today have the ability to drive 500 million species to extinction with its activities. The global growth, which is at 3% per annum, is producing more ill health than wealth. We have to understand. We are actually growing. If we are growing, the global growth, that is coming at a big cost. It is more of ill health that is actually propagating. Each month, 2,500 tons of toxic e-waste is being shipped from the Western world to Nigeria. Yet still a single European consumer, it consumes 50 tons of our planet's resources each year. So as we see with our, increasing lifestyle, more and more we are depending on gadgets and electricity on these resources. So we are actually becoming a burden to the earth, each per capita also. So actually, how much more mass expansion of human enterprise do we need? We really have to now question ourselves now. How much more do we want to expand? Okay, this is another photograph showing the disappearing ice caps, so which are actually robbing the polar bears of both their living space and food. Now, if I talk of pollution, so since 1990, India's carbon dioxide emissions from cars alone have increased by almost 88%. The world today has almost 800 million cars. Industries, to add on, they are also causing a lot of pollution. Then there are pesticides which are used for agricultural activities, which are again a major source of pollution in polluting the land and the water table. Okay, this is another photo. That's a waste incineration plant and its surroundings in Bangladesh. This is a lignite power plant which is contaminating the air with its emissions. Water is no behind rivers. You can see a surfer which is riding actually in a wave of filth and trash. Increasing energy demands, needless to say. So this is a nighttime spectacle in downtown Los Angeles, the famous Hollywood. So the energy demand is unfathomable. So it is actually increasing many folds. Okay, these are some of the scars left behind from the mining of oil sands in the Canadian province of Alberta. Okay, to the last drop, this was an oil field in California and its merciless over exploitation by the humans. Now another problem we are facing is the population explosion. So this is an overdeveloped metropole of Mexico City, if you can see. You can very well imagine what is the view. This is an aerial view. This is more than 20 million inhabitants in this city alone. This is another megatropolis, that is a view, and this is not very far from us, New Delhi, over 22 million inhabitants. So that is an aerial view of it. So the term is now called megatropolis. Okay, not a metro, it is a megatropolis. So actually we are destroying the human habitat with our own hands, with our own technology, and actually to no purpose. Okay, so now if I talk of carbon footprint, all right, since that is what our session is today about. So carbon footprint, if we all understand, it is a metric. It is something to measure the climate change. So carbon, if I try to split up the term carbon, the different greenhouse gases that are contributing to the global warming. So in the term carbon footprint, carbon would actually mean the different greenhouse gases, and footprint is what is the total impact that these greenhouse gases are having on something. Okay, so footprint will be calculated for something. So the best estimate it is of the full climate change impact of an activity. It can be an activity, it can be an item, it can be a lifestyle, it can be a company, a country, or even the whole world. So this term can actually be applied to a number of parameters. Okay, how does this origin, the concept? This comes from two terms, which is ecological footprint and life cycle assessment. Very popularly, we all know that as LCA. People who are actually involved in the sustainable development studies, they might be understanding these terms. So if I talk of now ecological footprint, so it is actually a measure of what is the demand of the human on Earth's ecosystem. It is a very standardized measure of the demand for natural capital that may be contrasted with the planet's ecological capacity to regenerate. So what is your demand and how much the ecology can actually regenerate on its own. So it represents the amount of biologically productive land and sea area which is necessary to supply the resources a human population consumes and to assimilate the associated waste. So how much can be consumes, so how much that can be productive land and seas required for that, and how much waste can be assimilated by the resources. So using this assessment, it is possible to estimate how much of the earth or how many planet Earths it would take to support humanity if everybody followed a given lifestyle. So we are actually trying to see how much land and productive sea area will be required for such kind of activity. First of all for the resources, and then when we are disposing the waste. Okay, so for 2006, humanity's total ecological footprint was estimated at 1.4 Earths. In other words, humanity uses ecological services 1.4 times as fast as the Earth can renew them at its natural pace. So that is a way to understand this term. So if I talk of ecological footprint now, okay, so basically carbon footprint, the built up land, the forest, cropland, pasture, all the fisheries, so they are actually compared to how fast nature can absorb our waste and regenerate these new resources. So what we are using it in is in the term of energy, in terms of timber, food, seafood. So all these resources are being generated by the earth in terms of its cropland, its fisheries, its forest, its built up land, and carbon footprint. So that is how these terms do actually relate. Okay, now if I talk of the life cycle assessment, the second term that we mentioned a few slides back. So life cycle assessment, as you all understand from the term, it's a life cycle analysis, an analysis over the entire life cycle. So it is actually related to ecological balance, and we are looking at a cradle to grave analysis. Cradle is from where it started, and to its grave, its final disposal, how it's being done. So what exactly comes into play is the production. How was it produced? How was it manufactured? How was it used during its useful life? And how was it finally disposed? So what was the environmental impact around these four activities of the cycle? So it is actually, the LC is actually a technique we are trying to use to assess the environmental impact associated with all stage of a product's life. So actually, if I try to put it up in a very layman form, from the raw material extraction to its manufacturing, to its distribution, to its use, to its repair and maintenance, to its disposal or recycling. So all these aspects have to be taken care of when we are actually looking at the life cycle assessment. Okay, another picture showing it how it's to be done. So it's actually a cradle to grave view of a product. So the first one to our left, that's the resource extraction, when we actually extracting the resource, say from forest or wherever. Then how it is manufactured, and again energy is being consumed, there is some impact on the environment. Then how on site, on construction site, how it is actually employed. Then when it's occupied, how it's maintained, how it's occupied, when it's occupied, how it's used, how it's maintained. Operation maintenance is the next. Then the next stage would be its demolition, a building we are talking of, and the final would be how it's recycled, reused, or disposal. So we have to actually look at the all the aspects. Okay. So if I talk of an measuring, how to measure this carbon footprint, since we have not understood the basic concept behind it. So we all know the basic idea, what we are trying to do here. So carbon footprint is actually calculated in a term called carbon dioxide equivalent. That is how it is denoted, CO2e. So it is carbon footprint is calculated as carbon dioxide equivalent, and what we use is a relevant 100-year global warming potential. Now, what exactly is this global warming potential, commonly also called as GWP? So it is basically a relative measure of how much heat a greenhouse gas traps in the atmosphere. So it compares the amount of heat trapped by a certain mass of gas in question to the amount of heat trapped by a similar mass of carbon dioxide. So we are talking of many gases, so they can all be converted to an equivalent of carbon dioxide. So that is why it is called a carbon dioxide equivalent. So how much heat would get trapped by a certain mass of the gas. So actually it is amount of heat that is trapped, and that is also over a specific time interval. Commonly it is 20, 100 or 500 years. So it is then expressed as a factor of carbon dioxide, whose GWP is standardized to 1. Okay, so to give you an example, the 20-year global warming potential of methane, a very common gas, is 72. Now, what does 72 mean? If the same mass of methane and the same mass of carbon dioxide are introduced into the atmosphere, methane will trap 72 times more heat than the carbon dioxide over the next 20 years. So that is how this number is calculated. So methane is actually trapping 72 times more heat than the carbon dioxide, equal mass. Okay. So some of the greenhouse gases. So what exactly is the effect here? Why are they becoming so important? So as greenhouse gases, they are released into the atmosphere, they accumulate and they form actually a barrier which traps the heat created from the sun and increases the temperature of the earth. So there was a Kyoto Protocol which originated at the third conference of the parties to the United Nations Convention on Climate Change. This was done in 97. They identified 6 major greenhouse gases, so whose atmospheric concentrations are strongly influenced by human activities. So these were these 6 gases that were identified. So one is carbon dioxide. Its GWP is 1. Sources mostly burning of fossil fuels. Then is methane. Okay. Then 23. So this is actually a number over 100. The number we looked in the last slide was for 20 years. This is over 100 years global warming potential. So methane is very commonly being emitted into the atmosphere through human activities such as cattle, landfill sites, leaks from disused mines, burning fossil fuels. Another one is nitrous oxide, almost 300 times more heating potential than carbon dioxide, again coming from our fertilized soils. Sulfur hexafluoride, not to mention 22,200 times. This is coming from electronics industries, electrical industries. Then there are perfluorocarbons in the range of 5 to 10,000. They are also coming from electrical industries, fire extinguishers. Then there are hydrofluorocarbons ranging from 12 to 12,000. They are coming from our air conditioning and refrigeration systems and also LPG storages. Okay. So what exactly is this? So as we have all actually seen, these greenhouse gases, they are emitted through transport, through land clearance, through production, through consumption of food, fuels, manufacturing goods, materials, woods, roads, buildings and services. And if we all see, all these have become a part and parcel of our lifestyle. We cannot actually, it has become difficult for us to give up all these things. We have actually made these a very important part of our lifestyle. So a single item or activity, we should understand, can cause multiple different greenhouse gases to be emitted, each in different quantities. So actually, why is this important? We'll see. When we are calculating the carbon dioxide equivalent, you have to understand each activity, there may be a number of gases and they are in different amounts. So it has to be the carbon footprint. If written out, it has to be, it can be pretty confusing also. So a carbon footprint is that's why it is generated to one common carbon dioxide equivalent so that they can be added. So we are actually adding apples to apples, not apples to oranges. Okay, so the total climate change impact of all the greenhouse gases caused by an item or activity rolled into one and expressed in terms of amount of carbon dioxide, that would have the same impact. Now, what is the importance of this carbon footprinting? Why is that important? An individual, a nation, an organization, its carbon footprint can be measured by undertaking a greenhouse gas emission assessment. So once you know how much you are causing the harm, you can actually do something about it. Okay, the number might impact us, so we actually need to know what is the harm we are causing so that we can actually take some remedial measures. Okay, so basically there is a need to reduce this carbon footprint. Okay, so major contributors again: population, economic output, energy, carbon intensity of the economy. Okay, so they have to be our main targets if we have to tackle this problem. Okay, so the most effective way to decrease a carbon footprint is to either decrease the amount of energy needed for production or to decrease the dependence on these carbon emitting fuels. Okay, so either the amount of energy for that you're using for production, that needs to be decreased, or dependence on these gases. Okay, so construction industry, as we all understand, since we're talking of green buildings, so buildings, that means construction industry. So what can construction industry now do? So if you talk of this industry's, construction industry's footprint, how is it contributing to this? One area is the construction materials itself, then the process of construction, what are the activities, then all its lifespan operation. Once the building is made, it is operating during its lifetime, and then again the eventual demolition. So this is where this carbon industry, construction industry is contributing. Okay, so with construction sector accounting for upwards of 70% of greenhouse gases, so they're actually accounting for more than 50% of greenhouse gases. It has actually become a mission critical for this industry to minimize their footprint. So what are the issues and risks that are in question right now? So basically the climate is changing, and most have observed that the increase in temperature is very likely due to human caused greenhouse gases. So looking forward, the businesses, they will have to encounter, there will be a significant increased pressure to reduce their contribution. So businesses, they will be actually, right now it is voluntary, but in times to come, it will come mandatory. They will face pressure to actually control their activities. There will be a greater degree of scrutiny over their carbon footprint. That is going to happen now. These businesses, they will have to demonstrate environmentally responsible practices to remain competitive in the marketplace. Actually, that is now, it's a big part of the corporate social responsibility, CSR. As such, responding to climate change will be one of the major issues affecting the businesses over the next decade. So how the businesses is not only about getting a good product out, but also about how much you're contributing to the environment. What is your contribution to this climate change? How are you tackling this problem? How have you made your processes better? What have you done? So now there is another, apart from quantity, there is a quality also associated. The quality in terms of environment. What quality are you giving to the environment? So in the very near future, so all facilities will be required to know and report their carbon footprint. So they'll have to actually know how to calculate it, then only they can report it as part of their social responsibility and asset management. So if I talk of the regulations, in the future, we'll be looking at more stringent greenhouse gas emission policies. Initiatives are expected to exceed the voluntary, so they're not just restricted to voluntary now. They have to be more now of doing nature. Policy measures have to emerge, include carbon taxes might come up that penalize greenhouse gas emitters. Emission trading schemes that target specific sectors. So there have to be trading schemes actually. Some people who cannot actually reduce, they somehow trade, they give some money so that they can trade in some emission schemes. Then carbon emission policies could significantly increase the cost. Again, we have to understand if this is happening, it's only increasing our cost. It will reduce the competitiveness, especially if regulations are not applied evenly. Okay, so companies that lead the way in proactive emission reduction in anticipation of a new regulatory environment may develop a significant competitive edge. So, you know, we all know this is coming. So rather than being reactive to these policies, we better be proactive. We know it's just coming, why not take an action beforehand? Okay, so they will of course be at a better position. Okay, so that is about the business. Okay, so for businessmen, again, this is one aspect. Now coming to the consumers, how are they? So public concerns regarding the negative impacts of climate change have moved to the forefront of consumer consciousness. Even now people understand that there are negative impacts, climate change is happening, people are actually feeling it. So you cannot have your consumer not know about it. So they already know. Even media coverage has become big now of all the environmental disasters, Hurricane Katrina, how well it was covered. So it is actually elevating the sense of urgency among citizens that there is a concern on environment. Again, people will start actually judging businesses on based on their track record of environmental impacts. So consumers might vote with their wallets by purchasing products and services from companies with clear plans to reduce carbon emissions and well-defined measures to minimize impact. So people might start going for green products. So if your business is not green, so you might be losing your consumer forum also. Then again, it is not about you, not about your customers. It's about your operational costs also. So rising operational costs due to strict regulatory requirements. If these requirements come up, your cost is of course going to go up, and emission charges will also go up. So though through either regulatory policies or voluntary commitments, carbon emissions will have an associated cost that will impact your profitability and cash flow. So they might become more escalating with time. So of course, we have to understand it is not only helping our planet if we go green, but it is also in terms of monetary, it is higher profit for you. Okay, so now coming to how to reduce this carbon footprint, that can be in terms of technological developments. There can be better processes, better product management. There can be a changed green public or private procurement, GPP, that is a term. So basically you have to procure goods, services, works with a reduced impact. Specific GPP criteria will be developed for a number of priority products, groups and services. So when issuing a call for tenders for products or services, criteria are used as a part of tendering documents. They might become a part of tender documents in the coming future. Only products that achieve these GPP criteria are considered for contract. So that is also happening now. So you have to basically capture what is the carbon emission, and you have to have consumption strategies, how you will do it. Okay. Okay. Another strategy is recycling the waste. Okay. So the Environmental Protection Agency that actually estimates that up to 85% of construction waste is actually recyclable. Okay, so when we talk of these buildings construction, so construction is a major part of the money that is going into it, and that is where we are actually generating a lot of waste at the site, and actually most of it, majority of it, 85% of it is recyclable, but we are just throwing it away. So that there is where lies a major opportunity to improve the environmental impact of construction. Okay. So how can we reduce this construction waste? Okay. So all the participants to this construction process, they have an important role to play. Okay. So you have to have some active efforts on projects by focusing on the role of contractors, subcontractors who are procuring and using these materials. So not only contractors, it is subcontractors also who will come into picture now. So achieving good waste minimization and management. So that is actually a good policy, waste minimization and management on construction projects. So that will reduce the quantities of construction waste which is sent to the landfill and makes a substantial contribution to the sustainable development. So it's actually two positive effects that we're getting. So waste that is generated, we are actually filling up the landfill less, and secondly, that waste can be put to some better use. So cutting back on waste would save the industry a lot of money. Okay, so many construction companies are actually sending their waste straight to the landfills, where most of the building materials with the right processes can be recycled. Okay, so products that include recycled content can be very well reused. This is not only reducing energy consumed to make the end product, but involves the use of a product that would have otherwise been sent to the landfill. So compactors that are used on site can also reduce the need for frequent waste collection. So you can use compactors, so that will reduce the volume. Lesser number of compactors, lesser transportation needs for sending this waste to the landfill. Fewer waste collection trucks on the road, and in the end, less pollution. So all these are little strategies. So you need to compact your construction waste. Then cutting back on the waste is actually a lot of money saving. Now, what exactly is construction waste? If I try to pull that out. So that is basically nothing but unwanted material which is directly or incidentally produced by the construction or industries. So these will be mostly be building materials only, insulation, nails, electrical wiring, rebars. There might be waste originating from site preparation such as dredging materials, tree stumps, rubbles. Construction waste, it may contain lead, asbestos, hazardous substance also at the same time. So much of this building waste is made up of materials such as bricks, concrete and wood, just damaged or unused. Okay. So observational research has shown that this can be as high as 10 to 15% of materials, and 22.5 to 5% is by quantity surveyors and construction industries. Okay, so construction and demolition debris breakdown. So residential construction, they are actually contributed 6%. Then there is non-residential 3%. Residential renovation, most of the construction waste coming down here 22%. Renovation of non-residential 19%. Demolition 11% for residential and 39% for non-residential. That is where this construction waste is coming. Okay, so there might be waste which might be because of the design and specifications that you had. There may be waste that is constructed during the construction activities. Okay, so again we need to understand when we are doing building design and everything, our design and specifications can also go a long way in contributing towards this reduction. So actually the amount of waste generated during the construction of a project when uneconomical design solutions are selected or when unsuitable materials are specified happens a lot of time. So design decisions impact on the level of waste. Okay, so type of waste that are involved, there might be dry lining in the form of cutting of plasterboard sheets and metals, studs to fit the wall heights and openings, then flooring, ceilings, insulation, tiling. So all these cuttings, you know, if in your design you can put some standard sizes which are used most of the time. So there will be less need for lot of cuttings, unnecessary, you know, 2-inch, 3-inch plus minus cuttings. If you can have some standard sizes used all over, economical designs, less wastage, less resources used. Paving, another way. Brickwork and blockwork, that's another aspect where we are generating waste. Okay, sometimes you know, we are into the habit of having inaccurate and surplus ordering. Then material doesn't get used, it is thrown away, just wasted. Damage through handling errors. So that is where your site management will come into play. Damage through inadequate storage. You don't have proper storage for your materials, so they are just getting wasted, they couldn't be used. Damage generated by poor coordination with other trades. Rework due to low quality of work. So all these aspects, if you take care of, a lot of waste can be reduced. Inefficient use of materials, temporary works, formwork, hoarding, they have to be properly reused. Okay. Okay, so basically there are financial benefits, of course, associated with the construction waste reduction. Financial benefits, of course, waste has a cost. You have paid for it, now you're just wasting it. Okay, which has been commonly overlooked. Many main contractors, they have the responsibility for waste disposal, although in most cases, the waste generated by subcontractors is more prominent. So clients, main contractors, subcontractors, they have to focus upon this issue from both an environment and a cost perspective. Okay. Now basically the benefit is to subcontractors also, financial and other ways. Okay. So total saving to the project, whatever you're saving, that is money saved is money earned. Okay. It will increase your profit. Okay. You can actually maintain your tender prices with reduced material cost. Subcontractors stand to benefit from using their materials more efficiently. Again, you can use that material somewhere else. Lesser wastage, more profits. Okay, so actually subcontractors can demonstrate a willingness to support and engage in waste reduction measures. And these demonstrations, they have an effect on the waste. They can improve the chances of being identified as preferred bidders. People might start knowing that, yes, they have less wastage. They might become a preferred choice for bidders. Okay. Again, the benefit is not only to clients, it is also to the contractors, but also to the clients. Okay, mostly what happens is this cost of wastage that is always inbuilt into your project cost. So if you're cutting down on this cost, it is a win-win situation for both the contractor and the client. Okay. So by reducing the total volume of wastage generated, a reduced cost for the main project can be achieved. So that will actually be a reduced cost for the project. So this cost saving, that can be a plus, which can be shared by the contractors, subcontractors and the clients. So a project which was earlier might be costing 100, say, it might start costing you 95 or 94 somewhere. Okay, this is already happens in partnering arrangements, and it could be introduced in other forms of procurement as well. Okay, so when we partner for all these things. Why not do it for procurements also? Okay, so basically, if we talk of material efficiency, product selection and waste management, there are two aspects which are very important. So they can be broken down into constituent parts with themselves. They both have an impact. So you have to minimize the environmental damage, reduce waste, less quantity of landfill space that will be used, reduced impact. And again, you have to conserve the natural resources. Okay, so the landfill that will have less of pressure, and your natural resources, they are also preserved. Okay, so who can take an action? It is actually a shared responsibility. We have to understand it's not about finger pointing or anything. Between all the parties of the supply chain, from the client down to the waste. As clients also, you can actually be very proactive about it. Okay. The guidance focuses on the role of contractors, subcontractors. Okay, they cannot work into isolation, so everyone has to work in cognizance. In order to ensure that everybody works towards a common goal, leadership is required. Then at the same end, that is where your management skills come in. Okay, so what is the client's role? You have to demonstrate leadership by setting requirements for efficient use of materials. As clients, you can say that on this project, we would like to have some efficient material use. You can communicate your requirement on waste to the project team. You have to ensure that the waste issues are considered and addressed. Okay, that the contractor knows that waste will be generated. He knows how he will address it. You have to ensure that all parties are fulfilling their roles in the effort to reduce waste. Now coming to the main contractor role. He has to deliver the client's requirements by developing a site waste management plan. Again, management is very important here. He has to have some clear estimates and targets of the waste that will be generated. He has to have a clear strategy how he will reduce this waste, and a very clear strategy to ensure the recycling of this residual waste. Then he has to monitor his waste data, ensure continuous improvement by gathering site waste data, comparing against estimates and targets, then collating subcontractors' quantitative records on actual waste performance. Again, so he has to know how much waste will be generating. Yes, I know it will be generated. Okay, I will do something about it. What will I do? How will I do it? And if I'm doing it, I have to compare it, what I had planned. Is it happening that way or not? If not, where did I go wrong with my estimates? So again, the management cycle is there. Okay, now talking of the subcontractors, they have to produce accurate waste estimates for their trade and supplying this information to the main contractor. Actions have to be developed to reduce this waste. And again, what will be the action that has to be told to the main contractor? That has to be recorded in your management plans. You have to affect the performance of the site. Okay, that will be radically affected. So you have to use materials in an efficient manner during construction, and wherever possible, ensure waste is minimized on completion. Provide accurate data on what was the wastage. See, the idea is it is actually helping you in benchmarking yourself. It is always a good idea to propagate best practices. People can know what that project has done. You should always propagate these practices. That will help you in planning your other projects also. So it is not always, if you have done a first effort, if it is not going in a good direction, you can still learn from those things. It is not nothing to hide. So you should always be tracking what you had planned. What is the data? Track it, report it properly. Okay. And again, identify why is the waste being generated and how can it be reduced. So go to the actual root cause thing. Okay, a best practice approach to waste reduction. Okay, so the driver for reducing waste needs to come from the client. Again, the client has to actually motivate the contractor. That will of course be a big binding on the contractor. Since the client wants it, I have to do it. That will be a big binding. So as part of the project brief, client needs to establish what waste is and why that waste is a very important issue. You have to challenge the project team to deliver a project that uses material efficiently. Okay, so they have to reduce, identify main contractor and the subcontractors. They all have to actually give their numbers and how they're going to tackle it. Okay, I guess I did say that before also. So again, the management cycle plays a big role. Again, planning. How will you plan? You have to plan. How will you manage your waste? You have to implement that plan. You have to review it and improve it. So it has to be a continuous cycle again. After improvement, start planning again, wherever you lagged. Okay. So planning will involve to develop a set plan for the management. Okay. Bring everyone into picture. Everyone should be involved. Okay, so targets set by client, estimate, and then the actions to reduce and of course to avoid. Prevention is always better than cure. What waste is generated has to be tackled, but what can be done to actually prevent this waste production at the first end. Okay. So actually this is something which is coming at the construction phase of your project. So if you talk of green buildings, so this is one major component then during the construction what was done. Okay, so practical measures to reduce waste on site, they have to be agreed at the planning stage. Okay, so that was implementation. Okay, so subcontractors, they actually have a chance to identify how efficient they were on the project, enabling them to understand how wasteful they were. So that will be the review part. So implementation of a waste minimization strategy for the project as a part of site waste management plan, that has to be there. If you're going for a green building, you should be doing this. So you'll be actually tackling a lot of the construction phase questions like this. So you have to develop a logistics strategy to minimize waste, use suitable, safe and secure storage, mechanical system, machinery, moving materials, all have to be considered. Off-site manufacture construction, that is also part of your project only. Whatever off-site manufacturing, whatever you're getting on your site from outside, they are also part, since we talked of cradle to grave analysis. So whatever materials you're using on your site, wherever they are manufactured, whatever practices are there, they're also contributing to your building's carbon footprint only if you end up using that product on your site. Okay, use packaging in an efficient way, very important. Packaging, most of the packaging, we are just throwing all those things. You can, actually give it back to your supplier. That can be reused. So you can actually stress on packaging that can be reused. So that is one way. Again, educating people is very important. A lot is about if you have the best facilities in place, but the people, they are not actually having a temperament to do it that way. If they don't have the attitude that I want to reduce it, so the policies are of no use. So people actually have to have that kind of attitude, that temperament. They have to be trained, they have to be educated for that. So your construction team, all people who are involved, they have to be also made aware. Okay. You have to allocate personal responsibility for waste reduction. Unless someone is made responsible, the work actually goes just like that. So someone has to be made answerable for these activities. That can be in terms of incentive, giving incentives to people in case they reduce waste. Sharing experience, again, best practices, they should be shared. Training toolbox on waste minimization, more interaction between estimators, that is very important. Okay, so review of waste performance, that has to take place when each work package is completed. Okay, it is not that one good practice is, rather than having a review at the end of the entire project, a project which might have stretched over 4 years, 5 years, you're doing a review at the end. So it's better to do it in packages, have little milestones for yourself. Each work package, as it is completed, you can keep on going a review of how you did well with your waste management plan. Okay, so when each subcontractor completes their work, review can be done, assess whether the waste minimization was effective or not. So this lesson learned can then be implemented to the next work package. So learn what works and what doesn't work in reducing your waste. Sometimes the same strategy might work for a particular geographical area, but might not work for the other. Different kind of people, different kind of projects, they are all unique. They have their unique demands. So we have to actually see what works best for that particular situation. Okay, so you have to also keep into mind what is the efficiency of your contractors. Okay, then improvement has to be there. Okay, it's not that just made one policy, it is there, always there, not being actually reviewed. If it's being reviewed, there are problems, you have to improve it, so that the basic idea of having an efficient waste management, that is always intact. Okay, so by improving its performance, company can demonstrate best practice and a company-wide commitment to waste minimization and management, and that will of course be an improved reputation for your clients. Okay. Again, we have to understand it is not only about the improved picture of your company, but also it is a financial benefit. You are delivering the projects at a much lower cost. Again, best practices, please share the lessons, people can learn from it. You have to promote innovation. You can championing new ideas, again, in terms of incentives. Okay, clients, contractors, subcontractors. raise awareness among people. That will of course help. If people are sensitized towards the issue, they will definitely be more prominently contributing towards reducing these waste. Demonstrate better financial and environmental results. You have to actually, if you have done something, you have achieved something, show it to people. That sometimes people say that these are just bookish knowledge. कहते हैं, it is not actually practically, if you go to the site, these are not possible. So actually, if you can demonstrate that yes, there have been better performance, there have been better environmental results, better financial results, that will actually more endorse your ideas. So you have to actually bring out these concepts so that other people can learn from it. Not only your company, even outside your company, people can learn from these things. Okay. Again, a very good idea is again to go. If we talk of this waste minimization, you know, it is in the form of an reverse triangle. The first is reduce. If you reduce it, that will do the maximum contribution. Then is the reuse, and then is the recycle, which is at the tip. So you have to reduce the waste at the first place. If you cannot reduce it, try to reuse it, whatever waste is generated. And what cannot be reused, try to recycle it in the form of recycling or composting. Instead of sending it to, so sending it to the landfill for dumping should be the last option. Okay. Now again, in terms of waste is something which we have talked about. Now water consumption on sites when buildings are being made, that is another big contributor. So carbon footprint of a facility can also be cut down by water consumption reduction. That can also help you. So actually water is obtained through desalination, which is a huge energy consuming process. We have to understand. So potable water which is for drinking, that may not necessarily be required at the construction site. So you have to see what is required, because potable water is after a lot of, you know, lot of processes been done on it, which is a heavy energy intensive processes. So use low water plumbing fixtures, efficient landscape irrigation systems at your site. Use recycled grey water systems. They can help you in managing your water at the site. So use water and grey water recycling tanks. That can be very easily done. Reduce the water consumption of the building you are developing. Okay, so see what is the water consumption, the building that you are developing. So that has to be taken care at that point also. So there are actually 3 zeros that are very popular. So we should be aiming at a zero carbon, at zero water and zero waste. Okay, now choice of materials. Waste is one, water is another on a construction site. Now choice of materials also can go a long way in improving your carbon performance. So the choice of building facade can make a dramatic difference to energy consumption. Needless to say, we all understand this. So glass, most of the time we like to put glass on the facade. So that is a big part of your building envelope. So that will play a big role in how much heat you are actually inviting inside your building. Unwanted heat, more of air conditioning, more of heating, air conditioning will be done, which is more energy use. Okay, so that has to be kept in mind when you're using materials for your building, what kind of materials you use. Okay, again, try to use daylight to the maximum. Keep the heat out, unnecessary heat out. There are a lot of high performance classes which are there, which can actually help in a better performance of your building envelope. Okay, these days there are a lot of systems like geosystems, okay, retaining walls, steepened slopes, drainage, improvement of soft ground, existing slopes. So as well as the construction of earthwork roads and pavements, they can be used here. So these are all major construction activities. You can actually go for geosystem. So there is reduced volume of excavation due to reduced footprint of the ground engineering structure, reduced need for engineered backfill, okay, less wastage, less consumption of higher grade construction aggregates. Okay, aggregates, we all understand, you know, that is becoming actually very expensive also. Reduce construction haulage from low volumes of material import, and reduced use of high embodied carbon materials such as steel, concrete and primary aggregates, which are actually they are having a large volume of embodied carbon inside. So go for geosystems, they are there. If we talk of steel, steel is one of the most recyclable materials. We have to understand it's a very strong, at the same time, good strength, good recyclability. It makes it possible, since it is very strong, you can build light and stable structures with less material consumption. It is easy to work with and never has to dry. It saves a lot of time on the site, and again it can be recycled. Okay, try to go for local materials that are available to you. So source the materials from your local, reduces the need of transportation. Okay, whatever unnecessary transportation of materials from faraway places, use what is available on your site. That will actually drive into your site also. It knows the temperature there, everything, the climate, it's used to that climate. It will, of course, perform much better. So it will have a lower site impact also. Try to go natural. Use natural materials like wood, stone, wherever possible in a sustainable manner. Okay, they use less energy to manufacture than steel and aluminum. Of course, now if I'm talking of wood, I hope the question doesn't come up. We don't need to cut down trees. Of course, you have to see there's a lot of wood that is around. You can recycle it, use it. So you have to go in a sustainable manner, plan it in such a way. Okay, putting in place a vegetated roof. You know, your roof, which is of course a major part of your envelope, major of the heating rests apart from walls. So that if you put some vegetated roof in place, so carbon footprint will definitely reduce because of less heat coming inside. There will be less AC requirements. Okay, they actually filter also air pollutants deposited from the atmosphere, and they also store carbon dioxide. They're also filters for you. So the atmosphere around your building will also get better. Earth covered buildings, a very old concept, a very noble concept. So that has emerged as a perfect building concept for Australian environment. They have actually worked on it. So environmentally sound, it is energy efficient, and it looks beautiful. It's protected from disasters such as earthquakes, cyclones, bushfires. They have actually performed very beautifully. So earth covered buildings fulfill the emerging need for a way of living closer to nature. So actually we all understand we really need to now live closer to nature. So earth covered buildings, you can also look into this option. Okay, so actually there's another thing. So if wood is not destroyed, the carbon that was fixed by photosynthesis can act as a long-term carbon store. So this means that wood has a negative footprint. Okay, so wood is there, so it has a negative footprint. You have to understand. It is not emitting; it is storing carbon dioxide. So wood-based products such as paper and board packaging can also act as short-term carbon stores. So emissions associated with harvesting, transporting and processing wood products are small compared to total amount of carbon stored in the wood. So you have to keep that in mind. That is also a good option. That's why they say go natural. Okay. This is just a little how much carbon dioxide and all that is stored. If I talk of timber, you see its carbon dioxide consumption storage per ton. This is storage in this term. That is why it's a negative number. Steel 2400. Timber is going minus. Concrete columns, beams 180. PVC 2200. Roofing tiles 137. Okay, so we can see the difference here. The graph is also very well showing the negative thing. Okay. So there are a lot of other materials that can be compared. Now again, the idea is when you're going for a building, you're planning it, you're designing it as a client, as a contractor. When you're planning it, you can always, do a little survey, a little research, a little study, a little homework on what are the different type of materials that can work for my purpose of this building. So you can do such kind of comparative studies to see and then come up with something that what is locally available, what is good for the environment, and come up with a material that can be employed to this building. Okay. Minimizing the use of cement, of course, we all understand cement, a major contributor of carbon dioxide, although the concrete industry now is doing good. It has actually come up with many sustainable practices. So concrete is actually, a lot of things are coming up now, they're becoming green. So again, cement, because demand is driven by a retrofit and repairing the existing structures, cement is a major consumer of this construction industry. It is the most voluminous manufactured product in the world. Okay, so LEED, it recognizes leadership in energy and development. So that is one of the agency that is rating green buildings. It recognizes the value of reducing the carbon content of concrete as innovation in design. So if you have innovation in design, you're actually getting extra points in your ratings. So we'll discuss that later. Okay. So it try to consume less concrete for new structures, consume less cement in concrete structures. So that will basically be 30% cement savings. And if you consume less clinker in cementing material, you will be doing a 50% clinker savings. Okay, minimizing use of cement. If I talk of that, you can have some architectural concepts actually and structural designs which will minimize the consumption of concrete. You can go for some composite beams. Okay, that is one option. Again, we have to actually come out of our old thinking, jo chal raha hai, we have to go with that. Most of the time with the houses, we give work to the mostly the thekedars are given the work. They're like, we have been doing this for so long. Ab tak chal raha hai, ab badalne ki kya zarurat hai? So that is something as clients maybe we can put our foot down that no, we need to go for something new. We have to, because jo chal raha tha ab tak, that has done lot of damage. So something new has to be done if you have to achieve something different. So their mindset again plays a big role. You have to do some of your homework. Okay? Highly durable concrete and mixtures for foundations, other massive structural members, precast columns, beams, detail for each assembly, disassembly, reassembly, prefab. That is a big prefabrication. That is a big contributor. You can actually reduce a lot of waste because they're actually already tailored sizes. They just have to fit in. Wastage is very less in these cases. Okay. You can actually another thing, you can start looking at the 56-day strength for structural elements instead of 28 days. But anyways, that is something with the code we cannot we're not here to question that right now. Okay. Minimizing the use of cement again, plasticizing chemical aid mixtures instead of water and cement to obtain required consistency, size and grading of aggregates that can be optimum so that total volume of cement paste in mixtures is reduced. Blended post-blend cement and concrete mixtures, high volume of complementary cementing materials, coal fire ash, granulated blast furnace slag. So this is how this actually concrete is going green now. Natural calcine pozzolana, silica fume, reactive rice husk ash, they all have been actually used to replace cement in the concrete mixes now. You can actually use crop residues also, industrial waste products. They can be alternative fuels for clinker production. Now it is not only about आपका cement mix में what you are using, even the way of producing cement for the clinker production, you can go for some alternative fuels instead of burning coal. So you can also look into those things. Again, project management, very, very important. Again and again, just like site management, your project, manage it, monitor your progress, team up with some sustainable consultant. There are consultants who can actually guide you through the process from start to end. How can your building, when it's being planned, it's being designed, it's being constructed, so someone can be there. Sustainability is built in. It has to be built into all stages of cycle, from funding, procurement, design, construction, production, manufacture, operation, maintenance. You have to monitor again your energy efficiency on regular basis. That is very vital. Then energy used in day-to-day running of any construction company. That is the biggest emitter of carbon dioxide. So your day-to-day operational energy costs are the highest. So if you have a structured energy efficiency program in place, you not only reduce the carbon footprint of operation, but at the same time you are having less of utility bills also. Okay, so not only to in the environment, it is a direct impact. So it is basically about tangible and intangible benefits. So tangible, you can see right in front of you, lesser of utility bills. Intangible, better environment. Okay, site location again. Since we're talking of houses and everything, site location plays a big role. Okay, so you have to, when you're planning residential or commercial buildings, you have to see that all amenities are in close vicinity so that people are not, using a lot of transportation for daily needs. They can walk through your site. A walkable site is what is a sustainable site. That you have to reduce the transportation requirements, try to use the local products. Again, interdependency, byproducts of one that can be useful to others. Try to have such strategies on your site. Okay, so carbon footprint, if I talk of a building, so there are emissions from the energy used in the building. Then there are emissions from the transportation to and from the building. So if I talk of a school building, 100 people are using that building every day. 100 people, how much cars, whatever transportation they're using, coming and going, that is also part of your building's carbon footprint. Energy emissions from the energy used for providing water to that building, water usage, and whatever was related to when it was constructed. That is always there. Okay, so construction, operational, all these things are there. Okay, so embodied carbon emissions are mostly 20%, which is construction materials, construction activities. The operational are almost 80%. Okay, so heating, electrical consumption during the lifespan, that is almost 80%. Okay, so actually embodied carbon, that is 20%, that is also important. So you have to also become energy efficient at the same time. Okay. Now, talking of energy efficiency, since energy we all saw is a major contributor while we are using it. So building envelope, as I talked of, your walls, your roof. So try to have cavity walls, better insulation. You can actually see a better heat ingress, how you want it, cold or depending on the climate in which you are. So you have to play it accordingly. Double panel glazing windows are there. Then apart from building envelope, your orientation should be such you are actually welcoming daylighting, minimum use of lights during the day, natural ventilation should be welcomed. You should have some building management systems in play. So you have actually planned a good green building, but if it is not used in a proper way by the users, actually the purpose is lost in a big way. Okay, then you can have trees around your site. sustainability can be there. Then in terms of electrical and mechanical, energy efficient light fixtures are available, occupancy sensors, they can actually help you. So whenever there is a need, the sensors can see how much is the occupancy, accordingly the AC needs, the lighting needs, that can be automated. Okay, radiant heating and cooling. Okay, supply the heat directly to the floor or the panels, eliminate the cost of forced air system. Then you have high efficiency air conditioners, conservatories are there, insulating wrap surrounding the water heating, occupant behavior modification, very important, the way people who are actually occupying, how they are using it, that is very important. Water conservation is another aspect into your energy efficient building. Okay, so we talked on the site also, grey water recycling, evaporator for your lawns, for all your irrigation needs on a house, standard house, you can always go for a grey water. Okay, then water efficient fixtures are there, waterless urinals are there. Power generation, have some photovoltaic area on your roof for a heating needs, lighting needs. Solar power can be used. Other renewable sources of energy depending on your situation can be put into play. Okay, so there are actually a lot of guidelines. There are there US Green Building Council, LED, Leadership in Energy and Environmental Design. GRIHA is there, IGBC is there. So IGBC is Indian Green Building Council. So they are all there. They have a lot of specifications how you can go for it. Okay. So you have to understand whether you are an owner or a contractor or an architect. Design and construct buildings. You have to design and construct buildings that require less energy to operate than the typical buildings that have been constructed in the past. Okay, so we have to actually now come up to this challenge. Okay, windows again, they play a major role since they are a big part of your envelope. So they can be a major contributor from where heat can come, heat can be gained and heat can be lost. So heat gain is not desirable in hot humid climates, and heat loss is not very desirable in winter, in cold climates. So old is better. Okay, so these old windows, they were fabricated from old wood, they are denser, they are lasting longer. Okay, keep it importer, so let the buyer beware. Some sales people promote replacement as cures, but even the highest quality replacement can fail. So try to use whatever is old, whatever is already there, it already has some embodied energy into it, try to use that same material. So reuse, again the idea is reduce, reuse. Okay, maintenance, keep well maintenance. Okay, insulation, very important, proper window treatments. Most of the time windows are good, but the openings, the connections between the windows and wall, they are a major contributor where the heat gain and loss is happening. Okay, so that is where the windows might get ineffective. Okay, again preservation is sustainability, I already said this. Okay, repair and regular maintenance and repair of your building, that must be taken up in a very comprehensive manner. Okay, so there are ways to reduce your carbon footprint, be eco-friendly, save on energy cost. Okay, you have to invest in very highest levels of energy efficiency for new homes, even at its best. You have to understand, even if these things are coming at an initial high cost, but later on you are actually the payback period is actually very less. So you can actually, in the terms of reduction of utility bills, and actually all this cost is actually coming back to you. And we can actually even like I said, there is always a good idea to show your best practices, to show that these ideas actually work. Even IGBC has actually shown, demonstrated that over the years the green building costs have come down. So they have actually taken up case studies and shown that also. So with time, there was always a perception that green buildings are costlier, but no, with time, with more competition in the market, more revolution, more research happening, there are better products, better services available. So these things are even getting more actually available to the common public, more viable to be done. Okay, again, some of the don'ts. So don't rely on any one form of technology to solve your green issues. So work on a land that is home to endangered plants and animal species. So if there is a site which is having an ecosystem where there are plants and animals which are endangered, so don't try to put up a building there because they are already endangered. Don't try to extend them. Okay, so don't try to send construction waste to landfills. Try to use your waste. सबसे पहले reduce it. Don't actually generate that waste. If you generate it, try to reuse it or recycle it. Don't send it to the landfill. Okay. Never, don't forget that there is something called as microclimatic influence also around your site. Okay, so your shading devices, if you use it properly, your fenestrations, your windows, we'll be talking of these concepts later during this week. So they can go a big way in actually controlling your microclimate of the site. So green building is not too expensive. Sustainable buildings are less costly to operate and maintain. We have to understand that. Okay, so basically you have to understand, you have to implement your design, construction and operational strategies to reduce a carbon footprint. So that will result in buildings that are more energy efficient, they are less costly to operate, they reduce the negative impacts on the environment. Okay. Now, since we've talked of carbon footprints, how to minimize it, now there is another term that comes, which is carbon offsetting. Okay, so basically, if you're trying to mitigate this carbon footprint through developing some alternative projects such as solar, wind, radioactive energy, or reforestation, that is called carbon offsetting. So approximately 65% of all electricity generated by power plants is used to operate new and existing buildings. So generating this amount of electricity through consumption of fossil fuels causes large amount of carbon dioxide. So basically, we have to go for some renewable sources. So if I talk of passive solar houses, so they are the simplest houses to make since we are talking of buildings. So go for passive solar houses. They are basically nothing but an architectural approach to solar heating and cooling. So sun that is available in abundance, free of cost, you're using it to your advantage to heat and cool your building as you like. So you have to use the forces of nature such as wind and everything, daylight, wind, heat of the sun, all that has to be used in a combination. These are all natural forces along with the fabric of the building, you have to understand. So the climate in which you are located, the building material, the envelope, they all play a big role. So all has to be worked in a holistic manner. So that is what is a solar passive house. Okay, so a solar passive house is the one which becomes its own collector, storer and distributor of solar heat. Okay, so it is actually collecting its own heat, it's storing it. Ease of construction is there, operation is easy, low maintenance and no extra input energy. If I talk of active solar houses are heated and cooled by active mechanical and hydraulic systems which are to collect, store and distribute solar energy. Okay, so there are solar collectors, pipe, ducts, rock beds, water tanks, pumps, fans, solar devices. So there are a number of devices that can now be solar operated now. Okay. Now, hybrid solar house is one which is using both these architectural and active electric devices operated on solar heat. So that can also be a strategy that you can employ. Okay. Now, there's another term, since you're talking of carbon footprints, there's another term which is called carbon neutrality, okay, which is nothing but a carbon footprint of zero. So buildings and activities that are resulting in a net quantity of carbon emission equal to zero. So we're talking of a net number that has to be zero. Okay, so first what you can do is you calculate the carbon footprint. What is the footprint of that building, of that activity? Identify the areas of its operation where reductions can be made. So it will not be possible most of the times to reduce the carbon footprint to zero. We have to understand most of the time it might not be possible. So what you can do is you can instead, you might choose, companies sometimes they choose to invest in projects that generate emissions reductions to offset the emissions that they cannot do internally. So if you can't do it internally, you can actually invest in some projects which are actually cutting down on these emissions. So you have actually contributed. Okay. So emission reduction, also known as offset, they are sold in tons of carbon dioxide. That's how the trading is done, in tons of carbon dioxide equivalent. And it can come from a range of products such as renewable technologies, green power, energy efficiency projects, land use change projects, and methane capture. So there are these type of avenues also that are available. If you cannot do it at your site, you can invest at some other place which are actually doing it. Okay, this is a little example about a household climate neutral strategy, how they reduce their emissions from 2000 in a span of 10 years. Slowly they went about it, and that's how they have reduced their emissions. So, you know, there was some simple things that they actually done. I'll just read those out. So they were using a lower water heater temperature, you know, how to control your AC thermostats. Okay, that can be one. Lower winter thermostats. You have to wash in cold water. You don't necessarily have to always use hot water to wash your clothes. Okay, air dry clothes. Instead of using mechanical dryers, go for air drying. Okay, use appliances, energy saving features, turn off unneeded lights, unplug extra fridge. Then you can seal your large air leaks, insulate water heater. Okay, cooking in your cooking kitchen, that can be another avenue where you can do some savings. You can replace interior incandescents, your lights, your equipment savings. Okay, doors, windows, your water pipes, they can be insulated. Water pipes, the water that you're heating and cooling, much of the heat is lost in transit, so that can be insulated. Okay. Then your thermostats, we already talked of it. Your insulation ducts, they can be insulated. Occupancy sensors. Okay, so based on the occupancy, they can automatically switch on and switch off. Air gaps on the windows, that can be actually sealed. So all these little local tree planting was done. So basically then they replaced the central air conditioner. Then they did some offset purchasing also. So these these little measures and all these measures in a span of 10 years, a household was able to actually come down to a net zero emission, right? So that was one of case study that was there. Now carbon footprint calculator, it is essential but impossible measure. Okay. So if you have to do some calculations, basically there are some standards. So life cycle analysis will be an important part if you have to do carbon footprint calculation. So there are standards for it actually. International Standard Organization, ISOs. So there is ISO 14044 and 14040. Okay, so these are standards that can be actually that can actually be referred to for the life cycle analysis. So basically the basic steps, if you're going for an organization, if you say I have to calculate mine, so you have to have some assessment boundaries. So what will be the organizational, how much will you cover, what kind of operations will be covered, and what are the greenhouses coming out of, gases coming out of it. Then you have to collect some data. Then you have to calculate the emissions using some emission factors. Okay, so basically you will get into play. What will come into play will be your electricity consumption, gas, heating oil consumption, refrigerant losses that are happening, your company owned vehicles. Again, I said people who are coming to your building every day, coming, going, whatever vehicles they are owning for that purpose to come here, the usage of your building. So that is a part of your carbon building's footprint. Business travel that is done by your people. Okay, commuting that is done, the waste disposal, how it is happening, and what are deliveries by the third party. Okay, your suppliers, your everyday consumables suppliers, raw material suppliers. So that are also impacting your number. Okay, so all these things can be actually have to be noted down. They have to be elaborated. They have to be identified if you want to do a carbon footprint calculation. Okay, now what happens most of the time, we have to be aware in calculating a carbon footprint. We should be careful that we don't end up doing a carbon toe print calculation. Okay, so instead of foot, it might happen that I capture just a small toe of it. Okay, so that is the most common abuse of the phrase carbon footprint, is to mostly what happens is we miss one of the major components. Okay, so the most of the emissions caused whatever activity or item is being discussed. So most of the time we don't identify properly what are the contributing factors. Okay, so many online carbon calculator websites are there. They will tell you that your carbon footprint is a certain size based purely on your home energy and personal travel habits, while ignoring all of the goods and services you purchased. Okay, so goods and services that are intact in your home, they're also a big part of your carbon footprint calculation. Okay. Similarly, it might happen a magazine publisher might claim to have measured its carbon footprint, but in doing so, it looked only at its office and cars while ignoring the much greater emissions caused by the printing house. Okay, so this is an example of a magazine publisher. So they looked at whatever is being done at their office, but printing house, which was a major contributor of their activity, so that was overlooked. So that actually doesn't take into care of the full picture. Okay, so you have to look at all the direct and indirect, not only direct but also the indirect factors that have to be kept in mind, right? So you have to identify it very properly. Okay. Another example is of a car. If I talk of a true carbon footprint of driving a car, it is not only the emissions that come out of the exhaust pipe, but the emissions that take place when the oil is extracted, when it is shipped, when it is refined into fuel and transported to the petrol station. So not to mention the substantial emissions caused by producing and maintaining the car. So that is a major contributor. So you have to keep that in mind. Okay. So basically, why is this carbon footprinting now very important for this construction industry, for greenhouses, green buildings that we're talking of? So they are a major, housing industry can be a major contributor towards sustainable development. So we can actually identify low carbon project options. that have potential to make carbon savings during design and construction phases. So there will be carbon savings during the building's operational lifespan. So you can promote building energy efficiency, use renewable sources. Then there can be benefits to the regional economy at the same time by promoting local construction. So you can give a boost to the local economy at the same time. Subcontractors, they can relatively have some low transport related carbon emissions. You can employ some contractors at that place. Carbon conscious buildings should be designed according to the sustainable urban planning in order to help reduce their lifetime carbon emissions. So your buildings, they have to be in line with the urban plan of that area. Okay. The results from a project's carbon footprint can also be used to benchmark performance. Again, it can be used as a benchmark, as a best practice for you to measure how you will go about with your future projects. Okay, there are social aspects also. The social aspects is project partner collaboration. Okay, so there has to be close collaboration with project clients, subcontractors, supply chain, and building occupants. So if you're doing it properly, then actually they all have to be actually interacting a lot of times at each and every stage. So that will be a good collaboration. So you can raise sustainability knowledge and awareness. Okay. Your team, they can be better educated with these kind of practices. Your occupants, they become better people, better better sensitized towards the sustainability thing. And again, general public, they will also, someone visiting your building, they also might get motivated seeing these things. Okay, so you can construct long life buildings. That's what you have to see. Okay, so if something is requiring very frequent repair, maintenance and everything, again, that is wastage of resources. So you have to go for long life buildings. So they have smaller footprints over there, extended life. Okay, sustainable urban planning. Okay, sustainable urban planning has to be done. Okay, that has to be kept in mind. Again, regional construction materials, economic aspects are there. Okay, lower transportation needs, then local economy. Okay. Then again, operational costs are reduced. You have to have some cost efficient, low carbon buildings. Okay, low carbon construction materials have to be there. You have to reduce environmental impacts during construction. And you have to be, buildings carbon footprint includes the carbon emissions related to construction process, which we have already understand of course at the time of construction and at the time of operation also. So that has to be understood. Waste management can go a long way. We have understood it quite well in depth. Okay, it is tangible and non-tangible benefits. Okay, so you have to promote energy efficient buildings. Okay, renewable energy will be coming into, if you're trying to do this, so you are actually by default, in many ways, you will be bringing renewable energy into play. Okay. Okay. So these are some of the case studies which are there. So I won't go into the details, but I would say we don't have to say that green buildings is a concept जो सिर्फ foreign का ही है. India, there are many good projects. They are there. So we can actually look into it. You can always go. There is a project in Singapore, which is a cogeneration plant. Okay. So they are doing their, they are using waste heat and gas from its steel plant to use their energy needs. Then there is Noida school. There are some schools in Noida. They have done some architectural changes, which has resulted in green buildings. Okay, they are zero discharge water system. Okay. Then there is an example very famous of Crossrails in Europe. Okay, that is a big engineering project actually, which will open in 2018. Okay, so it will make traveling cost across London easier and quicker. It will connect 37 stations. So they are going for wide, making it a green project. Okay, so we don't have to think it has to be done at small pace, big, small, always this can be done. So they're looking at braking systems, their tunnel alignments, all these things are being done. Okay, then there is another example of Hilton Hotel in New York. Okay, then there is a very award-winning case of Bedzed housing development in London. Okay, so basically they had a very holistic design that they kept in mind for green buildings. Okay, zero energy, high quality, energy efficient, and water efficient. Right, waste recycling, transportation, eco-friendly transport. That was a big part. Eco-friendly transport, low impact materials were there. Okay. Right, so there are many projects which are there. So basically the idea is of having an importance of carbon footprinting for construction industry is to learn from good practices. So it is still, although the carbon footprinting, this kind of term is still in its infancy, the knowledge, experience gathered on projects can be useful basis, can be used to carry out more comprehensive footprinting. So if you do it at small levels, that can always help in doing it for bigger projects and realizing significant reductions over the lifespan. Okay. So there are various ways in which your building can be made green. You can offset your carbon footprints. So you have to look at all different, even small things can go a long way. So that is what has to be understood. With this, I would close down my presentation. So when the last tree is cut down, the last fish will be eaten and the last stream will be poisoned. Then we will realize that we cannot eat money. Okay, so we have to understand money is not important. We can't eat money. We have to, at the end, it is air, it is food, it is what we need. We cannot eat money. Okay, so we have to think globally, please, and we have to act locally at the same time. Okay, so we should try to reduce our carbon footprint. Thank you. So with this, I close down my presentation. Any questions, please, most welcome. Centers, any questions? Does anyone have a question? You can please connect to us.
Indus College.
Okay, Indus, Kanpur, please.
Ma'am, how we can reduce the carbon by increasing the cement strength days from 28 to 56 days.
See, the idea of that, uska jo idea tha basically, we all know jo concrete hai, it always gains strength with age. तो 28 के बाद अगर आप 56 डे की स्ट्रेंथ देखेंगे हमेशा ज्यादा होगी 28 से. तो अगर आपका डिजाइन 28 की जगह 56 डे स्ट्रेंथ पे बेस्ड होगा, of course you will be using lesser size. But again, the code is saying 28, so we have to use that. So that is just a concept, in case we want to go for some innovations or anything like that. So zyada strength, yeah.
But 28 days, it's gained the maximum of its strength. After that, it's increased very linearly and very slow. Then how we can design for 56 days?
Yeah, no, that's what I'm saying. With time, it actually increases. So if you try to look at that parameter, there will be a change if you see. So you can look into that parameters if you can go into innovation. But again, we all have to do our designs as per the codes. We cannot go out of that jurisdiction. But in case you want to do some, case study or something like that, consider that. That's what is the point being noted here.
Can we have a copy? Ma'am, can we have a copy of this presentation?
Sure. I'll do one thing. Please, I'll send it to all the center coordinators. I'll do that.
Okay. Thank you.
All right. We'll do that. You can note down my email ID, himigupta.nitttr@gmail.com. So all the coordinators, they can send me their email IDs. So I will share it with all of you. You can share it with all the participants.
Ma'am, can you spell out the email Gupta?
Yes, HIMMIGUPTA Gupta. That's one word. Dot NITTTR@gmail.com.
Very much thank you, ma'am.
All right, most welcome, please.
Good. अच्छा वो बंदी भी छोटी है देश में बार-बार कौन
Baddi University, any questions, please?
No question.
Okay, thank you. We can move to the next. Khitan Polytechnic, Jaipur, please. Any questions?
Are there any questions?
Jaipur, any questions, please? I guess not. We can move to the next. Okay, yeah, Jaipur is here. All right. Yes, Sanjay Mathur.
Madam, we could not understand the 50 days curing with respect to 28 days curing.
Okay, I think अभी सबसे पहले वो कानपुर वालों ने भी यही क्वेश्चन पूछा था. Actually, the idea of that point was we all know that concrete gains strength with age. So if we start looking at a higher age strength, we might be, getting lower sizes of the material. So that was what the intent was. You have lower member sizes, so lesser use of resources. That was the point. So that can be done on case study basis or something like that, because code right now we design as per code, and code is saying 28 days to be used. So that was just, because when we talk of green buildings, there are always points for innovations also. So you can always go for something different. So you can always try that also out.
Okay, thank you.
Yeah. Yes, Siddharth Institute, Vijayawada, please. Any questions?
No queries, ma'am. Thank you.
All right, thank you. Any other has been left out? Hanji, Bathinda, any questions, please? Okay. All right. Centers, we are done for the day today. That is the end of day 1. So tomorrow, day 2, we start at 9:30. So all centers are requested to get connected in time, and please resolve your connectivity and audio issues so that the participants can actually benefit from these lectures. So we'll have, as per the schedule, we'll be starting with building envelope tomorrow, 9:30. So I request all the centers to join us in time tomorrow. Thank you and have a good evening, please. Thanks.